Check one, two. Testing, testing. Ooh, that's a daunting question.
Give it a test and see if it changes
It does. Perfect. It's a very expensive laptop just there. Everybody enjoying the conference? I'll wait for my prompt before I start. So.
Hello everyone, welcome to the talk. I'm Krishna Gade from Missouri. Hope you are having an enjoyable conference. I'm here to talk to you about generative AI and how it needs to be responsible AI and some of the risks around generative AI, how companies across the board are trying to solve
I'm not talking.
problems that we have to think about. So, I don't have to tell you that this entire conference has been about AI in some form or the other. We are in the midst of this amazing transformation.
This is not me. I could stand here and sound smart, but this isn't my... I'm not a ventriloquist. Yeah. Are we good? Yeah? Everyone hear me okay? All right, I'll wait for a thumbs up when I can start. These white lights are quite blinding. You good? Right. Awesome. Well, thank you, everybody. Thank you for attending this session. My name is Mike Leach. I work for Lenovo. We're here as a gold sponsor. So I'm very cautious of your time. I do not want this to be any time of sales pitch at all. But I wanted to spend some time with you to educate very smart people in the room on understanding the importance, I guess, of the underlying computing landscape in the world of artificial intelligence. It's this really cool thing called AI. You may have heard of it. For us, ChatGPT is the poster child that all of a sudden has made computing power from Lenovo and our partners at NVIDIA very relevant. But every single customer I speak to across the globe, there is a big disconnect between getting the actual intelligence out, where the data starts from. So hopefully you can take some time and learn from some of the information that I'm looking forward to sharing with you today. So I'm Mike Leach. I'm at Mr. Workstation UK on, I would say Twitter, but it's X now, as a friend commented earlier. Anyone like to follow me? I'm the senior manager at Lenovo. I manage a very talented team of solution experts within our worldwide workstation business unit. But as the world's largest PC manufacturer, we've got a lot of insight and a lot of AI that we use in-house, hoping to help share some of that with you. So this might seem like a fairly obvious slide, but it's something I show to every customer that we work with, that AI is definitely a journey, and it's not a destination. It's a new stream of business. It requires resource, budget, management, buy-in at the highest level. It's not something fake you can just switch on. The intelligence isn't just there. You've got to build it and maintain it. And I think that's something which we're seeing now as CTOs around the world are almost writing blank checks to bring AI in their business to save the world. But what we're actually seeing is that those blank checks don't last forever. And we're helping customers build and carve out their AI strategy that scales, both scales out and scales up as the use cases for AI grow. So for us, AI should not be pushed where it doesn't need to go. You need to look for a problem, either an inefficiency in your workflow or a pain point for your business. Find where AI can support that and then work back. You can put a round plug in a square hole all day long, but it's not meant to be there. So find the square plug and then use that, and square plug, square hole. AI is, find the business case and work back. It is something which I'm recommending to everybody. And then, things then will scale beyond the unscalable proof of concept that never goes anywhere, just spends money. Actually something that will drive efficiency for your business. So, I could ask raise of hands. So we're asking customers, where are you on your AI journey? That might be stage 0 where no current plans, I'm too scared to move forward. I'm hoping no one puts their hand up for stage 0. Stage 3 being the complete opposite end of that, where you're already deploying AI at scale. And then stage 1 and stage 2 is either where you're just pulling, open source tools, like an OpenAI style framework from cloud service providers, or whether you're building and training something in-house on your own data. So a quick show of hands, who's brave enough to say stage 0? That's an okay answer, but I'm hoping no one is there. Stage 1? Stage 2? Stage 3? Okay. So looking at each of those stages, the computing architecture, ultimately, it's almost like an iceberg. So much of that is hidden under the water that you may not have direct reference to. So I wanted to kind of see, well, look, within where do workstations fit and the underlying computing fabric within the AI landscape. So for us, we kind of split the market in kind of 2 areas. The 20% on the right, the integrated AI, that's in everything from Microsoft Teams and Office, Copilot type things from Microsoft. But it's the development phase where you use a hell of a lot of compute resources to actually get the intelligence there to prepare the data. And that's where, if we look at what organizations, if you get given a corporate issued laptop today, you can have it in any one of these 2 flavors, neither of which are typically, maybe appropriate for the job, and you just make do with what's there. So looking at that 80%, the frameworks, the tools that you would use within there, they all have much higher requirements than your average IT or, day-to-day, office administration tasks. And it's quite common that your IT decision team don't understand those software applications, so they're not providing you with the right tools. If we look at the integrated side, it's the wild west of off-the-shelf software tools, which is a great way to see AI inferenced and used within the organization. But obviously, the underlying hardware requirements for those are a lot different than what you have from the larger heavy lifting on the development side, actually creating the intelligence. So I'd say in the last few weeks, across the IT decision network, Microsoft announcements of Copilot has all of a sudden put the spotlight on how AI is important. And I think now's the time to help influence the hardware that you have access to make sure that your day-to-day jobs of creating the intelligence across your business are as efficient and as sustainable as possible. So, day in the life of a data scientist, it's not that well documented, but this was from the State of Data Science from Anaconda from this year. From last year. A workstation will excel at 85% of your day-to-day workflow. When time is money, sat there waiting to prepare data, cleanse the data, visualize, model selection or training, trying to do that on compute resources that come purely from the cloud, there is no such thing as the cloud. It is just somebody else's computer. So for us, making sure that you can be faster and agile, almost like fail fast, fail cheap, is where we're at. And that's typically where a higher powered computer workstation is built. And if we look at everything from, I would say, server cloud class deployment on the left, all the way through to then creating the content and consuming the content, we actually have a broad portfolio, but it's understanding, well, look, workstations are built to do the heavier lifting tasks of those data tasks. And then it's quite uncommon that, they are the go-to choice. So we're here to kind of highlight, well, look, the importance of the underlying CPU, GPU, memory performance is there to deliver the power you need to work on much larger data sets. So there are 3 types of computing platform: PC, workstation, or cloud. Most people will have PC and go straight to the cloud, as I've said, but the workstation sits in the middle and delivers a much bigger range of performance at a significantly cheaper cost than what it takes you to take things from your popular cloud service provider. So looking at kind of raw performance, we're not exactly where we are on the PC side. That's purely designed for inferencing. The cloud, a significantly bigger investment, or high-end server systems on-prem, significantly large performance. But a workstation is the best value for you to have that sandbox secure environment for you to then go and scale your projects wherever or whenever your business needs them. So why a workstation versus the cloud? So I've covered some of this, but for me, working with large amounts of data can be painful. Everything requires high-end CPU, high-end GPU, high-end memory. You don't have that on your traditional IT-given laptop, but you can have it from the cloud at a very attractive from price. But once you dial in the cloud, in theory, then you're kind of hooked on that drug, and the tokens and the cost of that obviously can be a little bit cost prohibitive at scale. So we're here to kind of augment that process. So imagine a workstation being the on-ramp to the data center. You want time and flexibility to then test and move before joining the highway there at full speed. So cost efficient, you get access to your local data very fast. You can fail fast and fail cheap. And I think that's the last piece I want to take there, is that the working and manipulating that large amounts of data is no longer painful if you have the right computing platform to do the job. And they scale very, very well. So scaling out with the broad configurations, you can buy a product and then add to it to grow in its flexibility as your AI needs grow. And then you can scale up and you can build, on-prem data centers of these style of products. Should your AI deployments be successful, if you want to build your own, generative AI chatbot and have it running inside your business. It might be a hospital, so you can't take that data outside of your VPN and your network. You can run it locally on a workstation. That could be your edge device, and then that could then scale. So they're very, very versatile. I won't want to endorse the Swiss Army knife, but imagine it as the Swiss Army knife of computing platforms that can be, tailor-made and suited to your needs. So we can start mobility. So quick show of hands. Who here does any AI development on a laptop? AI development on servers? AI development in the cloud? Okay. So by starting on a mobile workstation, we've done some numbers with probably our top 100 global accounts. And we're seeing cost savings of in excess of 80%, where turning down the cloud and winding up the laptop to balance those out, augment your cloud resources, significantly cheaper than to optimize your workflow on a more powerful laptop, to then make better use of company money on scaling to the cloud when it's right. We offer every form factor, every price point, every configuration needed. And we actually have some on the booth just outside for those that want to take a look. And then you move then maybe to more of a desktop platform. That can be something large under your desk. It's something that can be in the office and you use from home. You can remotely access all of these. And then they are that true on-ramp then to the data center, the large server clusters, and those that fall into then large cloud service providers. But we are seeing, I would say, competing strategies and priorities for the business. So we work very closely as the world's largest PC manufacturer directly with IT decision makers. But those IT decision makers, they're given smaller budgets. They're in business. Their main role is to make their life easier. So they have what we would call a restricted IT catalog. You can have any flavor of one of these laptops. It might be a 14 or a 15-inch, but that's all you get to choose from, neither of which are very appropriate. And their priorities around security, they're not necessarily at the table discussing part of the business AI strategy. And then in competing contrast, the data science team, they're the poster child of the organization at the moment. They're promising the earth and going to save the world. They're almost given unrestricted budgets. They have, the definition of what we call rogue IT. So they can buy any hardware that they need to get the job done. So they're buying something off the IT catalog that's less secure, that's not built for the enterprise. And in doing so, they're then dialing in cloud resources. So the CTO on the other side of the table is there writing blank checks with a growing, cloud service bill. And the CFO in the middle is just he's trying to save money on IT, but he's spending more money over here. And the collective answer is that when you're building out your AI strategy, you need to have all the key stakeholders in the room. And at the moment, we're seeing IT are not necessarily part of that discussion. And that's something we would like to see change, because the technology that underpins the success and the scalability of AI needs to have that IT decision maker. It needs to be an on-prem infrastructure conversation, either at the client side all the way through to workstation servers and beyond. And the overall cost savings for a business can be significant. You know, we have an example which we use in the retail space. We had a large retail customer that they employed 2 data scientists that came straight out of university as interns over the summer. They were given whatever they needed for this AI project, 2 basic laptops. They spent $750,000 in their popular cloud service provider because they wanted to try every scenario to come out with the perfect insight. And the cost of the workstations being $50,000, $60,000 were an expensive IT investment, so that was a no-no, but they spent, you know, nearly 10 times that overall in the cloud service providers. So overall, the business spent significantly more money to achieve the end result, and actually then having the right team at the table, if the IT team were aware of what the hardware is capable of doing, and overall with a CFO conversation, you know, we believe that there are, you know, significant savings to be had in different siloed areas of the business. And I challenge that, you know, let's see what we can do to knock down some of those. So I guess these are questions I'm going to ask. I'm not expecting, you know, real-time answers, but, you know, feel free to shout out. You say, what would reducing your time to insight mean? If you can get the valuable insight out of your data faster, does that change then how or where you deploy AI within your business? Are you constantly running out of cloud credits? You know, you having to go cap in hand to your boss to sign off on yet more compute power because, you know, you do have that unlimited compute power available to you. The all-you-can-eat buffet sounds great until you get on the weigh-in scales at the end of the month kind of thing. So, you know, you have to look at it and figure out, well, what's the most successful and an efficient way to use that? And then, are you aligned with your IT teams on the compute needs? Because the cloud is just somebody else's computer, and it doesn't come for free. They have to buy hardware, they have to maintain it, you're just leasing it on a per-hour basis. You can also look to save money and lease, you know, the computer hardware from, you know, your trusted IT provider like Lenovo. So you can have that device as a service on a monthly, a daily, or an hourly cost, so that it isn't a big CapEx investment. It can become a complete, you know, operational expense. And I can challenge, you know, who's looking to save money and operate more efficiently? It might be a bit of a, you know, a hard question to answer, but I think we could almost guarantee to save everybody here money in some way, shape, or form just by aligning the right teams with the right technology and putting that right technology in the hands of the right people at the right time. You know, data is the new currency, and we need to make sure that, you know, that data is used responsibly, and it's in the right place at the right time in the hands of the right people. Feel free to come and check out our booth. We're just outside around near the where the suites are on the bar. Thanks everyone for the time.
mic check?
Yeah, I'm trying to get a mic check.
Oh.
I mean, you're good.
Oh, am I good?
Ask him to turn this on.
Oh, okay.
Hello. Am I good? Okay, cool. Can you guys hear me okay? Yay. You know, I read somewhere you're never supposed to start a talk with, can you guys hear me okay? Most common phrase in all of virtual meetings. What is it? Yeah, you're on mute. Of course, that never happens to me. So I told Jess, I was like, this is going to be just like, you know, me and you having coffee. We're going to have a casual conversation. And a bunch of people staring at us. So it's very similar to what happens when we have coffee. So we're very excited to be here to talk about the next kind of advice that you can look forward to in early, mid, and later stage careers. So how many of you would you consider yourself early stage career? Okay, what about mid? Like 5 to, 15, 10? Okay, and later stage? Awesome, cool. So regardless of what stage you're in, if you're in the later stage, I'd be interested to get your feedback on what you thought about our advice for early and mid. But regardless of which stage you're in, I hope you can find some value out of our chat today. So we'll start off with some introductions. I'm Beverly Wright. I'm head of data science solutions for a company called Birchworks. We offer analytics, data science, AI solutions, like meaning delivery, projects, initiatives, data science products, as well as talent and training. I'm also the president for the Analytics Society at Informs, the Institute for Operations Research Management Science. And I'm the chair for the Data Science and AI Society at Technology Association of Georgia. And we have a booth on this floor. Please check us out. Lots of great events. And then I also host a podcast called Tag Data Talk. So take a listen. And then Jess, can you introduce yourself, please, ma'am?
All right, now? Okay. I'm Jess Ramos. I'm a senior data analyst at Crunchbase. We are a data company with company data. I'm also a LinkedIn Learning instructor, and I teach courses on data analytics and SQL. That's kind of my 9 to 5 life, and then I have a 5 to 9 life on social media. I'm also a content creator. I create content on LinkedIn, Instagram, and TikTok on data, SQL, tech careers, all that fun stuff. And I've spent most of my career in the SaaS technology space, kind of in the fintech finance world, and I'm just really passionate about sharing data with everybody and making it a fun field to be in.
And y'all, she's being like super humble, so please check out her LinkedIn profile. She's got, how many people were watching your SQL video recently, is it?
So far, over 5,000 in 12 days. I'm really excited.
Wow, I mean, my gosh. And average score was like a 4.9 out of 5 stars, so y'all give her a hand, like seriously. This is really, she's something. She's being humble. And we actually met through a mentorship, menteeship that happened organically. It wasn't like a preset date between like an organization like Informs where they have a mentor match or Women in Analytics or anything like that. It was just like, I came to Berry College initially, and through Tama Monroe White, Dr. White, asked me to come into her class, and Jess saw me, and then there was a poster competition for data science at University of Georgia, and I was like, oh, I know you'd be good at this. I know you would. And she went and did it and loved it, and then she got involved with Technology Association of Georgia. We did a nonprofit project. We have a For Good initiative in the summers where volunteers work on a data science project. Frank and Perrin, are y'all in the room? Yeah, Perrin's in the way in the back, and then Frank, I saw you somewhere. And they were also involved in this project, and so Jess was instrumental for helping with some K-means segmentation for that project. So that's how we met, and it's just grown from there. And now I consider her more, she's probably my mentor more than I'm her mentor at this point. But that's how we started this collaboration. So the reason we're talking about early, mid, and later stage is we really think there's a difference in the advice. We can't just give you a one-shot kind of advice, because early stage, there's going to be different kinds of challenges that you're dealing with compared to middle and later stage. also, not only does the market and our discipline change, because y'all think about this, we've only been around for a certain amount of time, right? This is not like math or, you know, even psychology. Like this discipline of data science and AI has only been around for decades, not like hundreds and centuries and that sort of thing. So things are going to change with that, and also your own self, you're going to change. So that's why, you know, we've sort of set it out in 3 different parts. Okay, so early career, Jess, I'm gonna let you take this part away. You're just getting started. You're trying to find your place in the world and in your career. What's your key advice points that you would give someone for their early career in data science and AI?
Okay, is this working now? No? Okay. So I think something I have really learned over the past couple years is how important it is to have a good manager. And I know that's easier said than done. It's hard sometimes to really find who you're gonna connect with and grow well with, but having a good manager can really set up your career and give you the chance to really not only grow your technical skills, but also grow your confidence. In my first data analytics job, I had an amazing manager. He was a mentor to me. He taught me a lot of technical skills. I felt really safe, and I was able to ask a lot of questions. And through that, I grew so much. I started out barely able to select one column in SQL to building entire data models and really driving insights throughout the entire company. And I just saw through that experience how important it is to feel supported by someone and really have someone who's going to be a good mentor for you. I think a lot of earlier career professionals are so caught up with the title. They want the cool data science job title or maybe a 6-figure salary for an entry-level role. But I think what's most important is being able to have someone who's going to nurture you and allow you to grow, because those skills are what you're going to be able to take with you to your next job, and they're going to help you out much more later on in your career.
Just to clarify, so you're in an interview, you're chatting it up with this person, you really connect, but the job is eh. You're chatting it up on this other interview, and you're like, thumbs down on the person, but the job sounds amazing. You're saying you'd probably lean more toward the first one?
Personally, I would lean where I think I would grow the most. So maybe kind of balancing like the skills you would learn, but also the manager. So just seeing what situation you think you would thrive in and grow the most in, that's the option that I would personally choose.
Okay. Great advice, great advice. And that's probably not something you could bullet, you know, like look for this, this, and this in your manager. It's probably very individualized. But I definitely have some things that I really like about certain managers and some things I don't like about one, you know, some others. But like John Williams is SEAN, if you want to look him up. He was my favorite boss of all time, you know, and I still think about some of the advice that he had and some of the ways that he made me feel confident, like you're saying. That's a really good point. Any other early career kind of stuff that people should look for?
Yeah, I would say definitely just work on overcoming your imposter syndrome. I feel imposter syndrome all the time still, and I certainly felt it a lot in my first data analytics job. There's just a lot to learn. There's a lot of coding skills, technical skills, everything's evolving and changing. There's all these new tools popping up. And then sometimes you're like, wow, I'm making these really big business decisions and I have such a big power in the company, but am I deserving of having that? It's natural to have those feelings of imposter syndrome, but I think everyone feels it to some extent. I'm curious if people later on in their careers still feel that. But I think it's just been kind of a battle to overcome those feelings and build up your confidence, because everybody brings something valuable to the table and everyone is a valuable asset to their company, no matter where you come from or how many years of experience you have.
Yeah, excellent, good point again. And you must have really overcome this because you're really brave with the LinkedIn Learning classes. You're in front of a green screen, right? And you're doing all this filming and it's permanent. You know, so that's a little bit intimidating, but those are fantastic points of advice for early career. And definitely easier said than done. We're not saying any of this stuff is easy, but it's we're just trying to highlight some of the things that are really important. And then mid-career, this is where you sort of start the climb. So I'll of examples from myself, and then I'll ask you, because you're right up, you're kind of like between the early and the mid, and I'm kind of between the mid and the later. But the climb. So when it comes to the climb, now y'all are going to think this is silly, but I'm telling you, this really seems to work for all the mentees that I've told. Write your mission statement. If you need to pull up a Franklin Covey website to figure out how to write a mission statement, write your mission statement, write what you're all about. and put it in your, I used to say write it down on a sticky and keep it in your bathroom. But nowadays I say, because I've been giving that advice for so long, nowadays I say put it in your notes of your phone. And so for me, to be completely transparent and to give you mine, I'm all about elevating data science, stimulating innovation, encouraging collaboration while doing as much good as possible. Those are the 4 things, right? And if you can't figure out your 4 and you don't want to go to Franklin Covey, I have a piece of advice, which is think about if you were a fly on the wall and like, okay, it's kind of morbid, but you passed away or something. And people from work were talking about you. You know, like, gosh, I just love the way she really made an impact in this area. Think about what you want them to say. I mean, a less morbid example would be a retirement party, but you know, what fun is that? So think about at the end of your career, you want people to be able to say like, oh, wow, she was really known for this, and I really admired that she did that thing. Think about what those things are, and that's how you can kind of find your North Star. So that's one example of ways that you can start, you know, thinking about mid-career. What are some other ideas that you might have?
Yeah, so I'm kind of learning this right now, so it's a special time for me figuring out what I really want to do. I think some advice that I would have is don't feel pressured to necessarily go down the manager track unless that's really what you want to do.
Yes.
I think a lot of people are so caught up with, I want to be a manager, it's the natural next step, it's a great job title, it's an elevated step in the company. But I think it's okay if you don't want to be a manager and you want to stay in an IC role. I was at a startup a few years ago. I was managing a team of 2, and I realized, wow, I'm really early on in my career to be managing people. I don't know if this is the route I want to go down right now. I feel like I need to develop myself more technically and work on myself as an IC. So that's what I did, and I almost felt like I was taking a step back to go back to a senior level, but I don't see it as a step back. I see it as a step in a different direction. So I would encourage people in their middle career era to really think about what they want to do and to not feel pressured into the right track or what people think they should do next.
Yeah, that's a fantastic point. I think I told you this when we were prepping for this, that sometimes I wish I were still just a senior data scientist. I mean, I get a little antsy not having hands-on keys more than once a week or something. But I still have my outlets. Like I still have the data science for good stuff that I can do. I can still publish articles. I can, you know, the last model I built was 2022, so I'm not like a dinosaur or anything. And I oversee all that, but sometimes I really just want to do it myself. So that's an excellent point. I try to tell people to sort of see your career as more like a jungle gym than a ladder necessarily. You don't have to go to the next rung. You can kind of go sideways. You can go sort of, you know, move around. Another piece of advice for mid-level is the ethics. And really, this kind of starts in the early stage, of course, and hopefully even sooner. But the mid-level, this is where you can really start to have an impact with the work that you're doing, and you will run into ethical challenges all the time. I had a colleague call me, she was almost in tears, and she was just so upset about one of their internal stakeholder clients, and it's at a major company here in Atlanta. And she said, I can't believe this guy was just like, I need the numbers to look this way, period. And it was her and 2 of her directors and 3 of her team members. And she finally just said no, you know, and there were teams chatting behind the scenes, and her team was like, you get them, you know. So please don't feel obligated, even though you will regret it. Let me just put it that way. You will regret it. I've probably been faced with this type of challenge from the ethical standpoint at least 10 times. I've been asked like to make things look a certain way to justify a decision that's already been made instead of relying on the data to help make decisions. So that's my biggest piece of advice for mid-career. Any others that you want to add?
Yeah, I've actually been in that situation too already, which is funny, but not really super funny. But I would say to really work on your soft skills. I think people are so caught up with doing all the cool AI stuff and machine learning and being able to code a lot in Python. Yes, those things are great, but I think what really takes people to the next level are the soft skills. So learning how to manage stakeholders, knowing when to push back, learning how to build relationships with them so they trust you and the metrics that you're developing, and just learning how to scope and manage projects and mentor people below you. I think those skills are often overlooked because they don't sound as fun as machine learning and all the cool stuff, But I think the soft skills are what really develop you into the next level of a data professional.
Yeah, great point. And that's what you always, that's what, I mean, at Birchworks, that's a lot of times what we hear is like, I need someone that's autonomous, that's proactive, that can think on their own, that is like naturally curious. Like a lot of it has to do with soft skills. One more thing for mid, and then we'll move to later. For mid, I would say don't be afraid to specialize. A lot of people are afraid to specialize because they feel like they're going to pigeonhole themselves and lower their opportunities. But I would think it increases your opportunities because you're known for something. And there's 3 ways to specialize. You can specialize by business problem. For example, you can say like, I'm the consumer loyalty queen. You know, I know all about consumer loyalty. I've done research on it. I understand it in and out, and I know how to build models for consumer loyalty. So that's one example, is you can do it by business question. Another example is you can do it by technique, right? Like I'm really good at NLP, for example. I mean, I'm not. I'm just saying that that's an option. That's an example. So you could be the NLP expert. I actually love structural equation modeling. Do we have any other SEM, structural equation modeling fans? Oh, man. Oh, we got one. Yay. Okay. It's so unused. It needs to be used more. It's like an incredible method. Anyway. And then the third option is you can specialize by industry. You know, so we have, I saw Russ's face somewhere. Yeah. So like healthcare, you can just be like, I'm in healthcare. You know, I'm in financial services. Like I'm in technology, right? Like you can just come up with what your specialization is, and don't be afraid to do that. Now, don't get so granular that you can't get another job ever, but do try to come up with what really makes you tick. So those are, I think, where we want to, those are some of our top advice for mid-career.
All right, Beverly, now that we've talked about early career and mid-career, can you tell us some advice for later career professionals?
Yeah, so when you get, so I've been in this for, it's hard to believe, but 32 years, y'all. Like I was a major in decision sciences at Georgia State. Any other Panthers in the room? Woohoo! Georgia State was one of the only only schools in the country that had decision scientists. And when I switched from accounting to decision science, I remember my parents making fun of me. Oh, are you going to be a decision scientist? Like, yeah. And now it seems like a normal piece of language, right? But back then, you know, my mom got a real kick out of it. So when I, you know, started on my journey, and now that I'm kind of looking back, one thing I would say for people that are 30, 25, 30, you know, years into this, make sure you're doing what you love. And I know that's probably for early career, that sounds silly, right? Like, of course,
A little bit,
like
yeah.
by then, of course you got it all figured out. But you change so much, you know, and you go on this like this system and this, you know, it's sort of the machine. And I've talked to so many people. One is a former CAO, 3-time CAO. Another is a CAO twice. I talked to them recently. They consider me their mentor. Hilarious. But I've talked to both of them recently, and they're both like, I was not doing what I love. I don't know. I just felt like I needed, because I felt like I needed to climb the ladder, and they ended up somewhere that they were not happy. So make sure you're doing what you love. And one thing I know for sure that I love, I mean, for those of y'all that know me already know this, my real passion is data science for good. And I work for Birchworks, and Birchworks has a Birchworks Cares, you know, division, and so they let me do that. And by working for Birchworks, it gives me the ability to do some of that. But if I could do data science for good all day long and help reduce opioid addiction and human trafficking and all that kind of stuff, that's what I would do. So one thing is, it might seem silly, but make sure you're doing what you really love. Another thing is reflect on your career. And again, if you need to write this in your notes, you know, by all means, but reflect on your career and spot clean, okay? So what I mean is look at everything you've done and then think about, like, is this the palette that I want? Is this the tapestry and the way it's painted? Is this the way I want it, or do I need to add some things? Like, make sure you do this before you retire. You know, are there certain things that I missed along the way? So do kind of like a status check on that. And then lastly, and you'll love this one, Jess, don't be afraid to take on mentors. Like, don't be afraid, like, to give back to the next. And that can mean talking at schools. We have Emory, we have Georgia Tech, we have Georgia State, we have Kennesaw down the road. Like, gosh, guys, there's so many opportunities for you to give back to the next. and they want to hear from you, right? So there are ways you can give back and contribute to the upcoming generation to make sure that your legacy kind of carries on and your passion is disseminated. Does that all make sense?
Yeah, I think that last part is great, and I think you've helped so many people. I think most people in this room probably see you as a mentor because you're a mentor to so many people, and I think that advice is relevant no matter what stage you're in as well. I think no matter where you're at in your career journey, there's always people behind you who can learn from you.
Agreed. What final piece of advice would you give to everybody here about their career?
I would say go for whatever you're passionate about, as cheesy as that sounds. Just be along for the ride, be adaptable, chase things that you're excited about. If I saw myself today 5 years ago, I would be like, no way, like that is not me. Like you just never know where you're gonna grow, in what direction you're gonna grow. But as long as you're doing things that you're like really excited about and passionate, you're gonna meet the right people, you're gonna find the right community, and you're gonna just be so successful. So just chase what you're passionate about, and you're gonna surprise yourself with how much you grow and learn.
Excellent, I love it. And I say stay curious, you know, be curious. It was discoveries and being able to make those discoveries that got me into this field and that sort of intrigued me. And it's always gonna be about that. It's always gonna be about making those discoveries and being a data sleuth. So stay curious throughout your career. Thank you, Jess Ramus, and thank you guys.
Testing? Okay. Guys, I apologize. We're just waiting for a podium. So once I have a podium, I'll be able to present, but my arms unfortunately aren't long enough to reach my laptop from over here. So I apologize. It'll be a couple minutes, and then we'll have a podium, and I'll be able to present. That's fine, yeah. All right, let's go ahead and get started. How's everyone doing today? Still hanging in there. All right, great. So today my talk, I'm Ian McKenna. I'm the director of field engineering over here, so I'm responsible for being the voice of the customer. My talk today is effectively just getting your data AI ready. So you have a lot of raw data and you want to get value out of it. That's what my talk is about today. So just to kind of set the stage, we only have about 20 minutes or so for this presentation. I want to show you a nice demo of how we do this. But effectively, where we start is a situation like this, where we have many different tables. The tables themselves are very, disjointed. There's, aggregations that need to be done. There is, there's potentially missing data. There's outliers. It's different sizes, different frequencies, right? And you need to take that data, right, that environment that may be in different data lakes, data warehouses, tables for sure, and create a situation where it looks like this, a flat table, right? So that is the input for any typical machine learning model, right? Regression, classification, and so forth. So the question is how do we get from here to here? That is what my talk is going to be about today, okay? Now, before I get into the tool that's going to help us with that journey, I just want to talk about kind of two key benefits the tool is going to be able to provide for me. This tool is called .data Feature Factory. Now, the first is that when you want to take your data that's disjointed like that and be able to gain insights, effectively perform exploratory data analysis from a machine learning lens, you have to do a lot of testing, a lot of exploration of that data, right? I mean, everyone is doing things like creating plots, creating histograms, looking at distributions, things like that, right? But you also want to generate potentially features, right, that are going to be powering the machine learning models. And so how do you do that today, right? You can't search for everything under the sun. If you have a small data set, a very small problem, a few number of columns, you may not necessarily need to do this. But if you have, a relatively moderate-sized data set or a big data set, it's going to take a lot of time to do that. So you talk to a subject matter expert, right? Or you build some domain expertise yourself. And you iterate with that subject matter expert in order to retract the size of the potential space that you're going to be exploring. What I'm posing here is a different strategy, which instead is a statistical strategy, where you instead are just letting the data speak for itself. So instead, you're posing many different questions, not just 10, 100, or 1,000, but I'm talking about potentially up to millions of these different questions at the data, and then you statistically let the data surface those features that have the most correlation, the most impact with respect to the thing you're trying to predict. So one example of how we can boost productivity is exactly what you're seeing right here. So in this example here, what I'm saying is, okay, let's pose one particular question to the data, right? Which is, first off, we have to identify what that question should be, which is typically either just simple, domain expertise or just kind of looking at the data and just kind of trying different things. So in this question, that is, do engineers who withdraw lots of money in the past month churn, right? That's something that we want to test the data set against. And of course, when you test things, it takes time. This is an example here of where if we were to do this manually, and it's coming from different databases, we'd have to potentially write some SQL code in order for that to happen, right? That could be more of a heavy-duty type of testing scenario. There might be ones where it's simple, just copy and paste from one Excel spreadsheet to another. But effectively, there is some amount of time required in order to test. And that's just for one simple hypothesis. In this case, the hypothesis is, do engineers who would draw lots of money churn, right? And if you want to do that at scale, you want to do that for 10, 100, 1,000, 10,000, and so forth, right? It just simply becomes impossible for someone to do that without some sort of automation capability. So what I'm going to pose you today is a tool that allows us to automate that testing, and then we can take our intuition, our knowledge, and we don't have to be a full domain expert, but we can take that and marry that with a statistical tool like this to really gather insights and jumpstart our machine learning process. The second thing that is typically a challenge when you are doing feature engineering, feature exploration, is that it's a process that's very ad hoc. It's very bespoke, right? So you're trying many different things. Effectively, you want to fail quickly so that you can succeed fast, right? So you're trying different things. You're not necessarily writing code that's going to be, battle tested. It's going to be like, it's going to be able to have like abstraction and encapsulation and things of that nature, right? Best OOP practices. Instead, you're simply just, banging out code that may not necessarily have great naming conventions. You're throwing it into different Jupyter notebooks. You have different types of data sets that you're working with. And when you do that for use case after use case after use case, you effectively, or what you're doing is you're creating technical debt, or you're making a decision to throw away these assets, these features, and these feature pipelines that you're constructing that could potentially be valuable in a new use case. And so what I like to pose is, how can we make reusability and sharing of these assets more forefront as compared to this previous approach? So, last slide, I promise, and then I'm going to jump into the tool. I just simply want to talk about the shift and how we're going to do this with a tool like .data. So above here, what you're seeing is effectively, sorry, let me just move this over here. What you're seeing is that we're taking some raw data, right? This could be many different tables from many different locations, and you're going to iterate with a subject matter expert, right? And effectively, you're going to continue to iterate, come up with new features. Maybe the window of period of time that you're looking at isn't quite ideal, and they say like, okay, 1 month isn't perfect. Let's try 2 weeks instead, right? Or maybe, hey, I've got a new data set. I want to enrich my existing data set with some new data and see if that has value, right? So you're going to continue trying these things over and over again, creating many different experiments. Effectively, you get to a point where you have a summary table, effectively a bunch of different features, right? And that can either be pushed into kind of a traditional feature store, right? Or that may be your end result, right? And you have all the features that you need and then you're good to go. Typically, what we've seen by talking with many different customers is instead, in order to, or trying to provide some reusability, they take the features themselves and store them directly within that feature store or that database of features. And then they'll take some sort of tool, like maybe like backwards propagation or some other tool to do feature selection. That approach of doing feature selection typically tends to be very slow, right? Because it's a machine learning based approach that's dependent upon the model that you're using. It's not model agnostic. And then you're selecting from that pool of features, right, to come down to a subset. So as the number of features in these summary tables that you're seeing here expands, that means also that your process of getting out the features that we care about here takes longer, right? Takes more compute. So how do we go about creating a situation where that's not a scalable, that's not scalable, right? We want something that is scalable. So what I'm going to show you here in .data is an alternative approach that can be married with the more historical-based approaches or classical-based approaches. So instead, what I'm saying here is that you have raw data, and instead of just talking with the subject matter experts and iterating in the beginning, save that for later, right? Instead, let's take that raw data, take it all and throw it like in the kitchen sink, just throw it all at the problem and see what surfaces. And there are 3 key things that we'll need to do in order to surface those aha moments. The first is that we need to define what it is that we're trying to predict, so that's the target variable, the prediction. We also need to define, if we have many different tables, how they're connected together. So what are the keys that connect these different tables together? So that's step number 1. After that, it will generate features. So then you want to explore potentially the features, or maybe modify the feature space, all the different types of combinations of these different features you're putting together, right, and constructing. So that's the second step, right? Explore feature spaces, refine it. Maybe, for example, you know there's certain columns after talking to a subject matter expert you do not want to include. Maybe there's some, HIPAA data that you don't want to include, or, specific demographic data, things of that nature. So that's the second step. And then the third step, the final step, is really just selecting those features from that leaderboard that you like, and then building the feature pipelines, right? And then using those feature pipelines in production. After that, your data is AI ready effectively. So what I'm going to show you here is that process within a tool called .data. Okay. So this is .data Feature Factory. It's a tool that effectively is a library that enriches your Jupyter Notebook by providing two key deliverables. One is an API that allows you to programmatically build these features very quickly. The second are these lightweight apps or user interfaces, like this one you're seeing here, that allow us to do feature exploration. It's one of the tools that I've noticed as doing data science that we tend to lack, is having feature-centric based exploratory data analysis tools, such as this one here. So that's one of the things that .data provides in kind of that lack of ecosystem. So what is this that you're looking at? This effectively could be an end result where you have, in this case, many different rows. Each one of these rows here is a feature that .data built and then surfaced as being statistically significant with respect to the thing we're trying to predict. I have not told you what the data looks like originally or what the thing is that I'm trying to predict on purpose, because .data, again, is a statistical tool, and we are agnostic with respect to the problem, the industry, or the use case. You simply take the data, throw it at .data, and then we'll surface those signals. In this case, just so you guys are aware, this happens to be determining whether or not someone is defaulting or not. And there's 3 different tables. Those are the key things you guys need to know about this data set. Now, when we are going through and exploring the potential features that have impact with respect to someone defaulting, these are the things that are surfaced in that data set. So what you're going to see are features that have many different types of components. Let me just zoom out here a little bit. So as an example, sorry, I'm just looking for my cursor. Okay, there we go, I found it. Okay, so what we're building here are many different types of combinations, effectively like Lego building blocks, putting these different components together to build these features. And so what features consist of are typically a couple of key pieces. They'll have a piece that's related to, as an example here, whether someone is, any record satisfied. There's some sort of aggregation piece. That's what this piece here is saying. So it's typically an aggregation piece. There may be a thresholding piece between different thresholds. There'll be pieces, as an example here, where there might be filtering based on different conditions. There'll be things like look-back periods of different windows in time, right? And so what .data is doing is effectively looking at all of that, including different interactions between different columns. .data will look at up to 4 different columns at a time. There's no other tool that can do that type of exhaustive looking through your data set. So simply because the number of interactions that you look at is exponential, right, in terms of the amount of compute. And the reason that we're able to do this, there's 2 key capabilities the tool allows you to do. One, it's built on Spark on the back end. For those that don't know what that is, that's great. You don't need to know what it is. For those that do, you'll probably appreciate the fact that this can scale. We build this on top of clusters. You can throw more compute at it. That's one of the reasons you can scale with big data sets. The second thing is when you are evaluating many of these different features, right? I'm not talking about thousands. I'm talking about millions of these different features. Typical approaches mean that you have to store that in memory, right? And obviously, if you have a lot of different rows and you have many different features, that just blows up. So you need a process, a way to do that in an out-of-memory approach that's also fast and accurate. And so that's one of the proprietary capabilities underneath the hood that allow you to really explore and scale and look at many different situations within that data. So effectively, you get to a point where you have a flat table that looks like this. And so the question is how did I get to this point, right? How did I get to a point where I can now explore and try different things? Like as an example here, this is being ranked based on the feature lift, right? So maybe I want to look at those that have the most lift, right? Look at just those first, and then expand my search to see if there's other types of features that are maybe of interest that maybe I want to socialize with the subject matter expert, right? Or again, maybe I want to make my model itself, I don't care as much about accuracy, I care more about being able to explain it, right? So I don't want collinearity between the different features. I want them to be as orthogonal as possible, right? So then you just simply change these different parameters here, and it will show you kind of the key things to look at first, right? And then you can further explore this in more detail. So the last thing I just simply want to show you here is how did I get to that point of building those features? So really, there are just, again, those 3 key steps I showed you in that slide. So the first here is setting the tables. So again, you just define as many tables as you want. This is in a Python dictionary, so I can have 5, 10, 15, whatever amount of tables that I need. I connect them together or define them here. The second step is I define the connections between those different tables. So an example, I have a transactions table and a clients table, and I'm connecting it based on the client ID. And then the third step here is just simply defining what it is that I'm trying to predict. What is the type of problem, in this case a classification problem here, and I'm trying to predict default, which happens to be in the loans table. After that, .data will go through and construct the features for you and the pipelines themselves, which just through a simple command called select features here. So you get out the feature table, that flat table down here, and also the pipeline too, where you can select certain features of interest, right? Which is the first thing that I showed you in this demo here, which is effectively just this down here. And you can decide, okay, these features do make sense. I want to include that in my feature pipeline, or maybe I don't, right? From there, you can then generate SQL code or take that pipeline, save it to disk, load it up in another Jupyter notebook, and then deploy that. So that's effectively .data in about 10 minutes or so. Do we have time for questions, or are we past time? We have time for questions? Okay. Questions? Yes, sir. How do we handle leaky features? So that's a great question. So there's actually technology in here that allows me to first detect whether or not there are leaky features inside here. So there's underlying technology that allows me to look at making sure that there's a certain period of time. For example, we're doing time series-based data, that we're not using time series data that is in the future, right? So every time that we're looking at like a window of time, we're making sure that we're only using that historical data. Yes, sir. That's another good question. So one simple way that we do that is that if data is above a certain threshold of missing in a certain column, like say, for example, 90%, we'll just simply drop that. But you can customize what that threshold is in the tool. Question? How are the features being generated? So that's a really good question. It's also a very broad question. So to answer that kind of in a sweeping answer, the features are being generated by effectively trying different types of combinations in the tool. So there's this concept called the feature space, which I did not show you just simply for time purposes, but the feature space, which you can see here, consists of joins, filters, and aggregations. And effectively what we're doing is you can programmatically specify custom joins and filters and aggregations, but there's also a default feature space, which you're seeing right here, built directly into the tool. And it's dependent upon the context of your data. So it will go through and build different types of aggregations. For example, if I'm looking at distributions, it's going to look at the distribution of my account balance, right? Or transaction amounts or things like that. That's dependent upon the data, but also the aggregations themselves are part of that default feature space, which you can also customize too. And so what data will do is it'll take all these different combinations and try them all out. Of course, before it does that in a brute force way, we're going to be smart about it. We're going to profile the data. And if there's certain things that just simply don't make sense to do, right, we're just going to drop those potential combinations. Yes, sir. So the question was, there are certain columns, for example, like an ID, right, which just based on the way the data is set up, potentially could come up as being one of the top features. And how do you deal with that? Is that correct? Yeah. So there are two things that you can do. First off is that if you know there are certain columns that you want to disable, you can adjust that directly within the feature space. So as an example here, if this happened to be the ID, the feature ID, and we don't want to do those aggregations on feature ID, we simply deselect it. So that's one way. If we know beforehand, after the fact, if you don't do that, it'll just simply try out those different types of combinations, which of course will take a little bit more compute time. But at the end of the day, you'll see them inside your feature leaderboard. And so you can quickly remove those, right? So if I go down here, right, I can quickly search for those that are built on specific type of ID. So example here, district ID, as an example of something that's built on an ID. I can immediately see those that are I do not want to include, and I can easily remove them from my list right here by just simply saying don't include them. Yes, sir. Great question. So the question is .data feature agnostic? How are we doing the feature selection there? And so I just want to kind of demystify that a little bit. So when we are doing the feature selection using a tool like .data, you do need to know what the target is. So you do need to know the thing you're trying to predict. It builds features based on what that target looks like. And so if you do different things, like for example, if you're looking at churn, right, and you're looking at churn on a monthly basis versus a daily basis, that's a different type of target variable. There would be different types of features that would be uncovered based on that different target variable. Now, the way that's being done behind the scenes, and I can't give you too many details around that, but basically it's a regularization-based approach in order to identify those features. What I've seen folks, and you can do this also with .data too, is that you can run machine learning on top of that, where then it becomes model agnostic, and you're trying to tune the set of features that are going to then be passed into the model. But what we are doing here is we're selecting features on an individual basis, looking at each one of those and how they correlate with respect to the target variable. And that piece itself is agnostic to whether you're using a XGBoost model or TensorFlow model or whatever it is. The second step, which you can certainly do as a approach after this too, is that you got a list, a feature leaderboard of 50 or 100 features, which is, again, an input that you specify. Return back 50 features or return back 100 features. And then from there, you can then further refine that in a specific machine learning model by passing in a subset of those features and then iterating on that. Does that answer your question? Yeah. Okay. Yes, sir. Yeah, the tool out of the box does both. So we do, how do we handle categorical variables? So we do one-hot encoding, we do target encoding as well. We're also working on a couple other encoding techniques too in the categorical space. I'm not sure if they're in the newest tool or not, but those two are definitely supported right out of the box. Yes, sir. So the question is can I explain a little bit about the computing resource required? And yes. So the computing resource depends on a couple, it depends on your data effectively, that's the short answer. But it depends on things like the number of joins that you need to do between different data sets. So if you have many different data sets, and as an example, you have a time series-based join that's doing aggregation on a certain window of time, it's going to require more compute resources. Also, of course, the amount of columns in your data set, the amount of rows in your data set, obviously are going to take more compute as well. If you're interested in learning a little bit about how much compute would be required from a tool like .data, I can give you kind of a very general sweeping answer, but also we have a tool that is a calculator that allows you to see exactly how much compute would be required. But in general, if you want to take a data set that is, let's say, on the order of gigs in size, right, and you want to connect that with, let's say, like 5 different tables, you're looking at on the order of a couple of hours of time in order to do that compute. We're talking about like maybe like 5 hours or so, to give you an idea of how much compute would be required. Yes, sir. Yeah, so the question is what are the limitations on the target variable? So there are a couple of limitations that you should be aware of course. One is, how many different rows that I need to compute in the target variable. I believe our limitation right now, out of the box, and it's potentially something we could adjust to, is 10 million rows. So that's the number of rows that you compute for a target variable per experiment. So that's one. The other one is talking about more about bias in your data. So if you've got 1% or 5% of a particular class, can .data deal with that? And the answer is it depends. So if you have a very small amount of a particular label in your data set, .data will warn you. In this command I showed you above, we're talking about target leakage. There's also looking at things like the distribution or the different classes in the data set. And if you have enough of those, it will warn you that it may not necessarily give you accurate results if you don't have above a certain threshold, which I believe is like 5%. But it's also looking at the data too and the profiling of the data. So the answer is, I guess it depends. Yes, sir. By oversampling? You could do that, but that's not in the tool, so that'd be a step outside of .data. Yeah. Okay. All right, guys. Well, thank you so much. I appreciate the time and all the questions. Have a great day, guys. Thank you.
Hey, y'all. Good afternoon. I'm told our lavalier mic just broke, so I'm going to do this stand-up comedy style. Today we're talking about cracking the code, mastering the art of marketing to data executives. I'm Brian Mink. I'm the co-founder of Data Science Connect with my wife, Amelia, who's right over there. So a little bit about our background. If you hear my opening remarks this morning, you heard some of it. But our background is, Amelia's is in healthcare, mine's in legal, both of which are pretty interesting spaces. If you have any kind of data background or you're involved in data, those are kind of unusual places to find data or folks working with data. So we collectively have experience as buyers, users, and also developers of a variety of data products. So we've seen kind of every aspect of the life cycle and ecosystem, and then now with our company Data Science Connect, work with folks from all over the ecosystem, whether they be data scientists, data engineers, to chief data officers, to founders of tech startups that are marketing data solutions to large enterprises or small and mid-sized enterprises. And so we kind of see everything now through our experience with all of you guys and with our clients and partners. And so have a lot of experience and perspective that I'll talk a bit about. I also have experience as a corporate executive, both at a Fortune 300 company and then as in the C-suite of a large national hospitality chain. And Amelia has over 10 years of experience building communities, Data Science Atlanta, and then now Data Science Connect. So this really shapes the way that we view things. Our roots, Amelia was one of the original founders of Data Science Atlanta, ran that organization for many years, and that ultimately led us to Data Science Connect. This picture's from one of the last Data Science Atlanta events before DSC was started at the Honeywell headquarters in Atlanta, and packed house for Bill Frank's talk there. And that was really when we started talking about, like, wow, we're really on to something here. Like, Data Science Atlanta is really tapping into something that people want, which is community and connection. And that really frames a lot of the basis for what we do and the way that we approach DSC and helping our partners and all of you guys. So our perspective from our professional experience and from working with our partners at Data Science Connect is really multifaceted. There's a few things that we have found that are common themes when we work with data professionals and data solutions. One of these is that there are a lot of barriers to innovation, that there's a lot of really good technology that for one reason or another has not always caught on. And so figuring out how we address those barriers to innovation, how we connect really innovative technological solutions with organizations that are ready to buy and implement those is a core part of what we do, and helping data solutions tell their story to organizations that would benefit from their technology. We really focus on cross-industry applications. So not just one industry, not just siloed. I think what we've seen in working with folks across a variety of industries is there are a lot of transferable themes. And that's one of the first things when we first met each other, when we were talking about our experiences in healthcare and legal, we found a lot of commonalities, that a lot of the issues that we were experiencing were related to processes, were related to practitioner mindsets in those particular industries. And so a lot of the ways to go about implementing solutions, technological and data-driven solutions in those industries that historically have been resistant to that, you can learn a lot from each other. You can learn what's worked in healthcare, what's worked in legal, what's worked in other industries, and how do we transfer those learnings into other industries. And that's one of the benefits of this organization and talking with each other as you start to hear people say, you know, well, we did this at our organization and it really worked. And even though you guys are in a totally different industry, there's some transferable knowledge there. And that is really the heart of it, is the community and connection. You can learn all you want in school and from reading books and from playing around with various different technologies, but often you can learn it a lot faster and in a much more real and impactful and actionable way when you just sit down and talk to somebody and hear about their experiences, what's working, what's not working, and how they've handled that. And you can then take that and transfer it into what you're trying to do. Okay, so our community today has grown quite a bit, and a lot of this happened during COVID. So DSATL obviously had to stop meeting in person during that time. Data Science Connect, we had done by that point several conferences, could no longer do those in person. And so we started expanding virtually and hosting primarily free virtual events, and expanded to over 100,000 data professionals worldwide now, including 95% of the Fortune 500, 80 plus countries, and have hosted 250 plus events, some of which are our events, some of which were partner events with our clients. We've hosted those since 2012. And our community now is heavily executive. It's about half and half executive and practitioner, about 31% director level, 25% C-suite. And then on the practitioner side, a lot of data scientists, data engineers, data analysts, data architects. So we've got the full spectrum of data professionals, and so we get to see both sides of it. We get to see the folks who really have their hands in the data and who are doing the really highly technical work that's very important. We get to see the executive side where folks are more business-minded, more focused on the ROI, and then we also work with a lot of data solutions providers who are trying to market to those audiences, and so we get to consult with them on what's working for them and try to help them provide content that's going to be engaging to our audience. Okay, so that's fundamentally what we've become, is we are connecting enterprises and other organizations with data solutions, primarily by providing high quality content that data professionals want to consume. And that's going to be a core theme of this presentation, is when you're trying to market to these folks, you need to provide high quality content that they want to consume. So one of these discussions is the technological decision makers versus economic decision makers, TDMs versus EDMs, and we hear our clients sometimes use this language. The technological decision makers, kind of the practitioner half of our audience, is more focused on the technical details. They're interested in innovation and problem solving and understanding the latest technology and leveraging it. And they might be less concerned with sort of the short-term ROI. They're more concerned with solving a problem. And that's really valuable. It's a valuable perspective within organizations, and they serve a valuable role. On the other hand, you have economic decision makers, EDMs, who often want quick wins and cost effectiveness. These are your directors of data science, your chief data officers. These are the folks who've been tasked with a business problem, and they often have the technological expertise. They may have even been a practicing data scientist or data engineer or data architect, and now they have a more senior function where they are more focused on the bottom line, on the budget, on organizational priorities. And so they're focused on these organizational strategic priorities in a much different way. So it's not just focused on solving the problem as they see it, it's really focused on organizational alignment. So if you're an executive, particularly in a large organization, the organization already has a strategic plan. You're not coming up with a strategic plan as the chief data officer. The organization has a strategic plan that has been developed by the CEO, blessed by the board of directors. And so it's not your job to go off on your own and say, I'm going to solve all the problems and here's how I'm going to do it. It is to be in alignment with that organizational objective. And that frames the way that economic decision makers think, is they have to show at the end of the year, when I go and report my scorecard to the CEO of this company, how am I going to show that I was in alignment with what the organization has decided its strategic priorities to be, and what KPIs can I show progress on? How can I show that I move the needle on those particular objectives? So that's a key piece of the puzzle here when you are a data solution provider and you're thinking, how do I sell this to a data executive? You need to understand not just what the problem is and how they think, but you also need to understand what are their organization's broader strategic objectives and how do I fit my product within that strategic objective. And then another key piece of this is these folks are leaders within their organization. That's how they got to be where they are. They're leaders and they have a lot of credibility in their organization. So everything they do, they have to position themselves in a way that is maintaining and furthering that credibility. And so if they take a chance on something, like they take a chance on software that is not fully vetted, they take a chance on something that is not, from a security standpoint, not as sound as maybe other products on the market, they are putting their credibility at risk. So that is the way that they think, and they might be more risk averse than other folks like data scientists, for instance, who are just trying to solve a problem. This executive might be more risk averse because they understand that if this goes south, I'm going to jeopardize my internal credibility, jeopardize my ability to get resources in the future and maybe even jeopardize my ability to keep my job. Okay, so who is this data executive, this mysterious data executive persona? These folks, they tend to be business-minded, they are visionary leaders, and they often are overwhelmed with the amount of information that's out there. They're constantly trying to figure out what are our competitors doing, what are the latest technological trends, and they need to have all this information. It's very important that they know it, they know what's going on, but it's overwhelming trying to follow all of this information and trying to craft a vision while also, again, being very business-minded and often risk-averse. So those are the different priorities that they are juggling. And what this means is that when you talk to these folks, what you think their barriers might be, what you think their pain points might be, are in fact very different than what you'd expect. So often, a lot of times, they are issues, very specific issues with their legacy tech stack. We cannot implement your solution because we have X, we have X solution already that we've been using for decades, and we can't get away from it, right? This is a legacy solution. We've wanted to unwind it for years, but it costs a lot of money, takes a lot of political capital, takes a lot of work, a lot of bandwidth, and it's not going to happen this year. It might not happen next year. It might not happen in 5 years, right? So they've got a lot of these things that they probably stepped into that if they were to design things from scratch today in the optimal way, they'd do it very differently. But they're dealing with this legacy tech stack. They've got to deal with data silos throughout their organization. And we've seen it in the last few years, there's this increasing trend that more and more organizations have chief data officers or chief analytics officers or CDAOs or some similar title. But prior to the last few years, a lot of organizations didn't have anything like that. They had various different analytics teams within their organization in the various different business units that might be touching data. And a lot of that data is siloed, a lot of those people are siloed, and that still exists in many large organizations. So these data silos are something that they have to deal with. Again, it's a legacy problem. If you were designing it today, you might not do it this way. But as a data executive, you have to deal with these data silos, and that impacts what solutions you might be willing to invest in for your organization and the types of implementation issues that go into that when you've now got to figure out, all right, well, there are all these different business units who touch this solution. How do I roll this out to a variety of stakeholders throughout the company? And that gets to that last point, which is political capital, and that is that these executives are fearful of exercising their political capital on something that's not going to work. So if you're trying to sell your solution to an organization, you've got to overcome that hurdle. A good executive isn't going to be unreasonably risk averse. There are some risks that are worth taking. There are things that you have to do in business in order for the business to move forward, but it's a hurdle that you have to overcome as a solution provider to say, look, the risk isn't as significant as you think, or the risk of doing nothing, the risk of maintaining the status quo is actually much worse than taking this risk on adopting our solution because your data currently isn't secure, or because your PII is exposed, or because there could be an outage. There's lots of things that you could say potentially that would be risks that are worse from doing nothing than adopting your solution. But that's what you've got to frame it. You've got to frame it as this is worth your political capital for these reasons. Okay, so what this means for you if you're trying to market a solution to a data executive is that you have to cut through all of this noise. There's a ton of content for these folks to consume. You've got to find a way to cut through it and speak their language. You have to focus on use cases and business cases. So this is one of the biggest tips that we give to our clients that we work with in developing content for executives is these executives, if you start getting down into the nitty-gritty technical aspects of your product, that might be really, really interesting to a data scientist or a data engineer or a data architect or data analyst or someone who is technically minded. But as an executive, they aren't looking to get bogged down in that. What they want to know is, what does this do for my organization? How am I going to implement it? And then what impact is it going to have on the bottom line? What is the use case and what is the business case that I can take to other executives in my organization to say, this is worth spending our money, it's worth investing our human resources. And it's very important that you establish credibility from the outset. Remember I said they're fearful of taking the risk on something that's not tested. because it's going to burn their political capital. So you've got to establish credibility that your solution is a risk worth taking, or that it's a risk not to adopt your solution. So a few ideas for how you would market to this audience. Number one, tap into existing watering holes. So selfishly, we are one of those watering holes, so I would say Data Science Connect is one way of doing this. But basically, go where the executives are. Go where they already are to consume content. It's a lot easier to tap into an existing audience than to try to create that audience from scratch and build that credibility, particularly if that's not your core business. You know, a core part of our business at Data Science Connect is building that audience and providing that content. If it's not your core business as a solutions provider, you may not want to get bogged down in that. Partnering with other executives. So executives want to hear from other similar executives. They want to hear from like-minded folks. So if you're trying to tap into an audience of chief data officers, maybe you can find other chief data officers who might be your customers, or folks that you know, or folks that you meet at a conference like this, that you could have be on a panel, that you could have them do a talk. So find ways to tap into that audience by partnering with other folks in that audience. Benchmarking resources. So data executives are very big on benchmarking. They want to know what other organizations are doing, what others in their industry are doing, what the trends are, where their fellow executives see things going. So that is one way that you can get them to look at your content, is to provide some kind of benchmarking resource. And we'll talk about some examples of that in a second. Then leading with a problem or opportunity. I think a lot of solutions providers, they want to lead with their product, right? They're very excited about the technical aspects of their product. A lot of people who are founders of data solutions are CTO type folks. They are very technical people who understand the very technical details of their products and want to explain those to people. And on the data executive side, they're really focused with their problem or with their opportunity. So what is the business case for this? What use cases are there? So if you lead with that, you entice them with that, and they say, yeah, that is a problem for me. That is a really big problem within our organization, or I really wish we were taking advantage of that data. You lead with that, and then you say, by the way, we have a solution that solves your problem. And that's often a much more effective pitch than leading with your solution that they may have never heard of and may not realize that they need. And finally, developing a long-term relationship. So this is particularly true of large enterprises where even a senior executive is not going to be the sole decision maker. You really need to have more of an account-based marketing strategy where you're looking at various folks on the data team, various folks who are going to ultimately have to vet this product. And so having that long-term relationship can be very helpful, and it may not materialize into anything in 3 months or 6 months, but maybe in a year or 2 years, they'll come back to you and now, oh, we weren't ready to implement that solution before, but now we are, and you're top of mind now that we know that we're in the market for that type of solution. Okay, so I'll give you a few examples of how we've done this for partners. So one is the benchmarking survey. We had a Series C privacy startup who was looking to brand themselves as a thought leader in this space. They had a unique product that managed access to various different types of data as a way of managing PII. And so we did a custom survey for them focused on their ICPs, their ideal customer profile. And this is something that if they tried to do it on their own, you know, these folks probably wouldn't respond to them, but we already had this community that we were able to tap into, send these folks a survey, ask them to fill it out, and then we provided the results of that survey anonymized to everybody who filled out the survey. So we provided the benefit of, hey, you get this benchmarking as an executive, you get these results of this benchmarking survey that you can then use within your organization to inform your strategy. And it also provided the benefit to the Series C startup of all of this data, this rich data that they were able to use to both inform their audience as a thought leader and also to inform their product marketing strategy as they figured out, well, what aspects of our product are most important to our ideal customer profile, our data executives that we're marketing to. And the chief marketing officer of that company said, this is data gold. This is something we're going to use not just to inform our marketing strategy, but to inform our product itself. Okay, executive roundtables. So we did this for a Fortune 30 company that was looking to overhaul their marketing, their their product marketing strategy for edge computing and data management. So they were trying to market this particularly in the manufacturing and supply chain context, edge computing, data closer to its source, and they were trying to figure out what is it that we should be marketing with these products. And so we gathered some of their ideal customer profiles together in a room, some senior data executives from large companies, and they were able to ask them, what are your biggest pain points around data management and edge computing, and get valuable information in how they developed their product and how they ultimately marketed their product. And then finally, community building. So we had a Series B startup that was building a niche feature engineering product, open source community, and they were trying to drive folks to their open source community. So we were able to build several meetups for them, developed 1,000 members in less than 6 months, 7 cities in 3 countries, and then ultimately we were able to leverage that for several successful in-person events that they did around this niche feature engineering product. And that's another good example of community building. So once you build the community, then that community is there for you to take advantage of. And so you build that community up by providing quality content, by getting those folks into some kind of group that you're able to market to, and then to actually continue to provide that content and drive them ultimately to your product. So particularly if you're an early stage startup, this can be a really powerful thing. You know, you may not have the dollars to deploy for large scale events or, you know, elaborate marketing strategies, but it doesn't take much to start some meetups, to produce some content, to start getting folks using your open source product, and that can really lead you to a lot of key relationships and feedback on your product that ultimately will inform the conversations and features that you later market to your buyers of larger organizations. So we appreciate all of you being here today. Appreciate all of you being here today, and would love for you to partner with us if you're a data solution provider, and of course, for those of you who are here to enjoy all the content, we are so proud to have you here and happy that you're contributing to our community. So thank you very much.
Does this work? Higher? Like, okay. Okay, I guess we're on time. Well, good afternoon. Thanks for hanging out here, sticking with me. I'm Peter Molnar. I guess I am an OG. I was probably on, if you were in the previous talk with Brian, I was on a, probably one of these meetups, so I might have been in that picture. I started going like 2012, 2013, I started going to data science meetups. I used to be a computer science professor, then decided, well, you know, I went to these meetups, called myself a data scientist, moved to the industry, spent 10 years there, and then now I'm back in academia. I'm an associate professor with the Institute for Insight at Robinson College of Business at Georgia State University. Okay. Don't hear any cheers right now, but it's okay. And so we have a really, really exciting data science program. It's a technical program, but nobody is closer to business than Robinson. And so our STEM-based, basically STEM data science program is out of the business school, and we're working with a lot of industry partners together so that our students actually get the value of having practical experience right from the first semester on. So, but what I want to talk today is about how some of the concepts that are kind of diverting, the symbolic AI and the neuro AI, basically the you know, Gen AI, large language models, and so on. Everything has been neural network based for the last couple of years, and we had made like huge progress there, and everybody's talking about it. But kind of reflecting back is like how the last 50 years or so of advances in artificial intelligence have been, there are other concepts, how we can bring them in and how can they work together. And that's what I basically want to explore a little bit in this presentation here, is how we, you know, the strengths and weaknesses of each of these approaches. It's very difficult to show this in visuals, so here just some words, but the mathematical background is slightly different. So on the symbolic side, we talk about propositional logic and first-order calculus. On the neural network side, this is more linear algebra, gradient descent, so numerical methods. And if you think of back to the history, and actually the first sort of two original high-level programming languages that were created in the late 1960s were Lisp and Fortran. They're pretty much kind of matured around, or the first versions appeared around the same time. Fortran is basically what kind of sort of the grandfather of pretty much most of our programming languages that we can think of, C, Python, CUDA, anything. It introduced arrays, and that became, you know, the arrays of certain types, so we could create vectors and matrices, and that kind of lent itself to numerical computing. Lisp, on the other side, the designers of Lisp had something completely different in mind. They were thinking more algebraic, and having just some type of symbol representing an entity and looking at the relations between different entities and computing that. So that's kind of like the closest that we probably, or like you might see is, or you might think of is like, for example, graph databases. We look at RDF triples or something, we could think of them as symbolic representations. The symbolic side of the last, I mean, we have on the neural side, we have made major advances in the last 5, 6, 7 years. partly because the availability of new libraries, GPUs and CUDA, the computational capability and the availability of data, of course, has exploded. On the symbolic side, we haven't really seen these technical breakthroughs yet, but I wouldn't count it out that it actually happened, hopefully happens at some point. So if you think about it, symbolic, for example, graph databases, we have entities, nodes, and relations, vertices between them. On the neural side, we're always just basically thinking vector space, so vector databases come in, so kind of showing that. Some of applications for symbolic computing are, for example, Bayesian networks. This is kind of like a step up for you, those who might not be familiar with that. It's a step up from basic logic tables. So think about the dependency of we have the nodes here represent certain states. Like, for example, is it cloudy or not? And these, in this simple case here, are just logical, they're basically true or false, so Boolean variables. And so basically to see, let's say, okay, what is the likelihood, or is the grass wet? Wet grass is true. It may depend on whether it rains or a sprinkler is turned on, and the rain and the sprinkler might be actually depending on whether it's cloudy or other types of dependencies. So the Bayesian networks is a way we can build some reasoning in there, saying that certain things, if they either true or false, or have other types of values, and then build these logical dependencies. But with Bayesian networks, for example, we don't really have to just rely on the true or false. We can assign probabilities to that. And these are fairly powerful approaches, for example, that have been used in diagnostics algorithms or programs and applications. But symbolic computing and symbolic AI has basically the advantage built in of the logical reasoning. So it's built on logic, it's built on inference, and there's mathematical foundations like first order predicate logic, and then what you see here is actually Prolog code. So Prolog is a programming language that evolved around the 1970s to represent, basically for mainly symbolic computing. You can write numeric programs with it, but it would not be the most efficient way to do that. But the idea of representing knowledge, and then from known, and then a way to develop reasoning. So what you see here in this example is very simplistic, but let's say we have some type of entities, and we just call them Pam, Bob, Tom, Liz, Anne, and so represent symbols representing people. And then we have a relationship between them, and that's what you have. It's called a predicate, like a parent. So Pam is a parent of Bob, and Tom is a parent of Liz. So this creates a relationship similar to a graph database. This formalism allows you to do more than just binary connections, but nevertheless, you can come up with some data. That's basically it, the facts. So these are known facts. But from this data now, we can generate new rules. And we can say, for example, that we can define a predecessor. And the predecessor could be a parent, for example, but a predecessor could be also the parent of a parent or another parent of a predecessor. So building these type of rules allows us now to create new and generate new relations. And this is a very simplistic format where we can now use this, exploit this, and ask questions to our system. In this case, the system is very simple because we could basically just ask is, for example, who is the predecessor of Bob, or who is this basically who is a descendant of Bob, and find out all parents or all predecessors, pairs of predecessors. So this simple framework, but allows us then, being rule-based, to build larger, more complex problems and solve them. And the beauty of that is it's fully deterministic. So we can, at every time, whatever the answer is, we can explain it. It's all based on logical inference. Another example, symbolic, basically natural language processing, has been for a long time basically purely symbolic. We would represent words or even break them down. You know, if you remember lemmatization or stemming of words, you have basically symbols, and then having a categorize them in different parts of speech, and then define grammar trees. And these grammar trees, like basically, these are like formal, the formal syntax or the formal grammar of our language, can then be used to parse sentences and extract the meaning from that. So what you see here is on the left-hand side is a sort of very simple grammar for an English sentence. But then it basically allows you to parse a sentence, like for example, the dog saw a man in the park, and based on the grammar tree, now we know what is the subject, what is the object, and we can extract the meaning of this sentence from that. A lot of work has been, there's a huge body of work, of course, that has been done in the last decades. I put WordNet on here. WordNet used to be the #1 for the English language, the #1 catalog. And it was not only that it basically became like a dictionary for the vocabulary, but also relations between different words, like what are their nature, are like their adjectives or verbs, what is the antonym, what is the synonym, and so on and so on. So then, of course, on the right-hand side, you have this is just an example of I think this is BERT, like a transformer model. So the symbolic computation has been, basically has been around for a long time. And if you look at, this is a seminal paper, it was actually a dissertation work by Terry Winograd in 1970 or 1971. He created a blocks world. And it's kind of, this, if you heard of it, or if you go through that, the idea is to limit the domain, the knowledge domain of basically the universe, to of course, a very simple problem. So back then, 1970, over 50 years ago, it was a very simple idea of having a table with a number of different blocks, and you have some type of robot arm that can manipulate the space and pick up a block. But even back then, if you read the transcripts, and this is just an excerpt of the transcript, the amount of knowledge that was, I think it was actually already pretty expressive. Yes, I'm talking to Alexa all the time, and for most part, it does what I want to, and it even answers some of my questions. And it's much more, of course, a much broader domain that I can ask for. But this system was already able to process English language, respond, basically take questions, respond in plain English, and it was able to to take commands like modifying the space, the blocks world, as well as asking questions about that. So it was able to reason for that. It was also able to combine actions and plan. And so a lot of these things that are actually used for solving problems have been kind of introduced in that. It was a very limited domain, but nevertheless, it was, I think, a good start. And there's a lot of development that has been done in that space, and planning and the knowledge representation, that I think we could still benefit from a lot. And so, again, this is like the system, the blocks world kind of works on a state. We have a state space, so any configuration is a node in the space, and then we have some type of, we can define what are transitions from one state to another. Again, you can think of this more as a graph place, a graph in the state graph in the or state space in the logical, in the symbolic domain, versus what we basically in a neural domain we talk about vector spaces. So one of this is sort of an example in a group of problems, but even in that time frame, Newell and Simon developed a general problem solver. And I was going, the idea is like, okay, if I want to solve a problem, I want to do something, what does it take to get there? It's actually sort of a very natural way for us to solve a problem. And again, we would break it down. So, for example, taking my son to school, have to drive, is the car working, and so on and so on. So this idea of representing in a discrete symbolic state, we can represent our problem in our problem space, and then have algorithms to solve that. One of the things that, there's no question about it, is the scalability. A lot of these problems, even to this day, have been somewhat limited and have been limited in scope. We have a very small problem space, and most of the rules have been hand-coded. And there's definitely a challenge of scalability that needs to be overcome. For some, like for example, most of these algorithms utilize heuristics to expedite the search through the entire possible space of states. And and that is actually now kind of leading up to where opportunities are. But just to stick a little bit longer around, on the symbolic versus neural, there's still machine learning or learning from data. So for the neural networks is basically the backpropagation algorithm. We compute an error and backpropagate the weights. In the symbolic space, there is inductive logic programming, which is kind of like these rules that I showed you earlier. We can actually define, we can have algorithms, training algorithms to provide data. Here's again a similar example of defining a relationship. In this case, the example is a grandfather, which is a parent of a parent or the father of a parent. And how to come up with the rule based on some known relations, known predicates, that's our base knowledge, and then examples. And these are positive and negative examples. And basically what we want to do is we want to have an algorithm finding different types of rules that might be candidates, hypotheses, and then solve them based on the examples, our training examples that we get. The advantage of this is that this type of training is that we usually can we can get away with many less examples, positive or negative, or it might even work only on positive examples. And then whatever the output is, it is a rule. It's something that we can actually interpret and reproduce. So if this rule is defined and found, it will be the same output for any input. For example, here if the result would be define a grandfather being the father of if you have z, x, z, and y, the grandfather of x and y is the father of some middle person z, or and z is the father of y. So and I'm sorry, I'm actually jumping out. This is of course very wordy here, but there's definitely an advantage in the symbolic AI, which interpretability. We can also code our domain expertise. So if we have, as we think in business rules, we can integrate them directly. The rule-based reasoning allows us to really trace everything. We can explain. We can also ask questions of how something has come to a conclusion, or identify exactly where something, what would change the outcome. What we are lacking, and basically that's the strength of neural networks, of course, is the scalability and that we have, and in terms of like processing large amount of data and training on these data, and not having to do any manual feature extraction or stuff like that. But actually, that's kind of thing like going back and forth. I'm happy to share this. But here's basically one of the key, one of the applications that was basically during the 80s, 90s, was sort of the first, one of the first waves, I guess, of AI, which created a hype, but then also created a low, and we're kind of thinking probably Gen AI, we will have a high and getting a low. Doesn't mean that any of these technologies are completely obsolete. Usually it means there's some expectation which is not quite met, but eventually these technologies and these concepts will just basically go into other types of domains. And so the rule-based expert system is exactly having some knowledge base, having a rules engine that allows to do inference, to define business rules, find business rules, and then allow to, like, for example, question and answer. So common, or some of the popular expert systems, they have been all somewhat in the domain. Like MySyn is, you might have heard about it, is about infectious diseases, to discover them and make recommendation for treatment options. And there have been a couple of these expert systems around. One of the challenges is that they had to basically you have to have an expert who is sort of defining these rules. That used to be done manually by collecting the information. And then to build the knowledge base, which has like rules and facts. Rules engines is not so much of a critical thing. That's basically just the algorithm, how to solve them. There are different ways, but even that could potentially be expanded. And then the user interface used to be similar, like a query interface, which of course we have now. We can have technology, particularly with like language models, to build out a semantic search where you enter a sentence and that can be converted into a formal query that goes into the system. So just what I highlighted here in red, and this is basically all the things that we have been doing in the last couple of years and made large strides with large language models, foundation models, GPTs, so chat GPTs, and how we can bring them in. Now tapping into the vast source of data and text and what we have, information that we have, to extract the knowledge and build these knowledge graphs and building these rules that we can build in there. So I believe there's a lot of elements, a lot of points where these technologies and these concepts can be combined to basically build more powerful solutions. So I know this word is also pretty wordy, but just basically thinking of how to integrate them, how to use some of the symbolic concept combined with the neural concepts to basically build more intelligent solutions. I think I'm way over time, but thank you so much, and I'm sticking around for questions. So. I can't see anything so blindly. Oh. I think I got away. Can you put the slide back up? But I think we need to clean. So adding knowledge.
Yeah, adding knowledge shows the knowledge expert. That's the knowledge for the rule engine.
Right.
But in the red line, you mentioned like the search the internet.
So I think we can, so the old system did not have, so in the old system, it was on the classical system, it's experts would manually enter or program that, so they're engineers building these knowledge bases. The idea is, of course, now we can automate a lot of that. So that's for one. I think that's, I don't have a pointer on here, I think. But then on the lower one, in the rules engine, I was thinking of, like, for example, these examples that you do with LangChain now, like building a chat agent that is, using ChatGPT and uses this Google search. And the idea, I didn't go into the rules engine, but the rules engine is kind of similar. It's an iterative process where you find matching information in your knowledge base, and that could be like a natural way to integrate this as well.
Now, my question is that if creating the data by experts, that's kind of awesome, right? But isn't it losing importance when you search the internet? That's the kind of my point. Like you start really good, but once you enter the searching internet, I guess it loses the authenticity, isn't it?
Yes, so yeah, absolutely. You would have to be careful what you bring in. Absolutely. I mean, I absolutely agree with that. That's still a, whether you need to control what you come in, and if you just basically look at the search for the internet, it potentially opens up your system to whatever you build in. I mean, this is sort of just really high level, but yes, so you would definitely still, I mean, you still would have to build all these safeguards in there. And I think that comes to the point where we have these different technologies, and how do we integrate them? And of course, they're, not one solution, but integrating them to build, smarter solutions. So, all right, thank you.
folks must be waiting for the last talk of the day, so probably get started without further ado. H2O is incredibly, one more minute. That was a very good talk on good old-fashioned AI meets transformers. Thank you so much for bringing the history of it's been a while since I heard about Terry Winograd's paper. It's awesome to kind of introduce H2O to some of the audience here. Many of you are familiar with our community. How many of you have used or heard of H2O before? It's a very strong community in attendance. And like water, our dream was like water, to see AI everywhere, and it's kind of incredible to see that happen in a deluge of adoption of AI everywhere. So super thankful for the community for supporting us over the years. I think we are here mostly because of the incredible sacrifices of our team. It wouldn't be possible without the makers, past, present, and future. And we pay homage to many AI folks, not just this current crop of AI innovators, to all greatness. And we stand on shoulders of incredible innovations, both open source and closed. And it's quite a thrill to kind of present some of that work. With gratitude, we are here after COVID. Thank you so much, Atlanta, for hosting us. And we think of BC as before COVID. All data that we had before has to be rebuilt. Another theme, we've been talking about features and feature stores. I think from feature stores to feature story, kind of the story of your data is what's going to come in spades, thanks to Gen AI. It's going to also pay homage. This is our slide that has always been with us since a long time. It's in font Georgia. Thank you, Georgia, for saving the democracy a few years ago. Data scientists, extremely passionate about data. And I think, hopefully, we hope to all be talking about the stories of the journey. And the struggle is the story. If you're struggling with data, you're struggling with whatever you're doing in the world today, that struggle has a story behind, and that story is what you want to highlight, and hopefully Gen AI is going to take us there. Data science, obviously, is a search for truth, and between 0 and infinite, we're pretty much in that spot. With that, I want to jump quickly to kind of the story of today, which is how to use generative AI to kind of tell even more powerful stories. We'll do a fireside chat about with the LLM. H2GPT is 100% open source. It uses obviously Llama 2, and with 4 or 5 simple steps, everybody in the audience should be able to run a Llama 2 on your laptops, right? Sort of this is something that GGML allows you to quantize it and run on a simple, any hardware. So it's about 30 tokens per minute. It's not very fast, but it works. Okay, why, how should, well, I think, so let's ask Parmi, tell us how Llama 2 works. And I think, obviously, you're looking at several LLMs here in action. Llama 2, talking about Llama 2 here, between the 70 billion parameter model here to these 13 billion. This is the front page of most of our LLMs. You see, it's very choppy. HDMI here is not the best of a friend for NLP demos. Let's try again. I guess that's the software engineer's world of how to fix hardware is to reboot, right? So, so that's kind of Llama 2 explaining itself. Most of you have heard about the, someone was quoting, and earlier there was the Llama 2 attention is everything paper. So let's feed it Llama 2 paper and see what it does. And so this is, let's use RAG to kind of help us understand how is it different from Llama 1, right? So it's a very simple question. We're gonna feed this. Most of you have seen this paper. While it's doing that, let me just upload it here. So most of you heard of RAG. So this is essentially doing embeddings on this paper, kind of starting to kind of, it's a very well written paper. Many of you have not written it, read it, I would definitely encourage it. It's a good read. So what it's actually doing is essentially pulling up, doing the embeddings on the fly for you, and moving from a pure LLM mode into something that is going to answer based on the particular document. I think I might have, let's give it a few more seconds to see how long that works. By the way, how many of you are evaluating LLMs? While that is up, I'm going to pull up methods of evaluating an LLM. We have an eval GPT AI, which is actually trying to run LLMs to compete against each other using an ELO rank, very similar to how chess grandmasters compete with each other. So again, using one of them, the top LLM, as a judge, we found that March 14th version of Llama 2 of GPT-4 is a good is the best LLM currently out there as service. Okay, so now it's chunked, and per chunk it has metadata as well as. So let me just go and clear what we have and start asking a question. How does Llama 2 differ from Llama 1? Of course, we have a spelling mistake there. Let's see what it does with the spelling mistake. But I think, so long story short, it's going to have to actually answer from the document. So many of you are using RAG or thinking of using RAG. So this is obviously Llama 7B, which is a terse 7-year-old, is going to give us exactly the difference in parameters, but it's off. Let's see what Llama 70B comes back with. And I think these are kind of the beginnings of how we plug in model, how do we get results from document. The document actually does go into detail. Now, one of our customers is a bank, Commonwealth Bank of Australia. They use us for their next best conversation apps. They build us users for benefits finder apps. They have more than 1,000 models in production across a gamut of use cases, including credit scoring, right? Sort of fuel finder because oil was a little expensive. And here's a slide where they talk about how they use H2O. Now let's see if we can feed this one into one of our platforms. And I think, again, this is a little bit more enterprise edition of the same LLM and same GPT. So now let's take a view of of how this one does it. Again, I think I just loaded this a bit earlier. So while it's again doing the same thing, but even more, gives you access, fine-grained access. So let's ask a chat here. So describe in 10 ways how H2O AI is helping CBA. I'll put a question there. Again. What are you seeing there? So again, this is a little bit more nuanced because it has to go and check different documents, different inferences in the document, right? Sort of because there's references that go into the other documents as well, other slides. So between slides, it's able to give a very detailed answer of connecting different slides and telling a very powerful story on how much value they got from different page processing to so on and so forth. Like for example, you'll see the main slide obviously is there, but the sub-slide that is referred in the main slide is also pulled out. So you can see that with fair prompts, you can actually deliver some high-end kind of customer experiences on internal documents that don't need to go into ChatGPT or other public or Anthropic or other public services. So that's kind of the next phase of most of LLMs. Again, this is work in progress. Team's been busy working on building a very rich experience for our customers. For folks who have actually been following us beyond the open source, we actually have brought all of those together end to end, so you can actually see in an app store, right? Sort of that's the metaphor for solving problems that are focused problems. So you're going to see typically these days, if you're at H2O or you're a customer of H2O, you're going to see most of what we deliver as an application, right? Sort of, so how does so it starts with the data, right? Sort of, so the Data Studio allows you to do ETL on content, so bring different documents and create Q&A pairs, and then use those Q&A pairs to fine-tune, and these Q&A pairs are generated using LLM, so you can take a document and use that to teach the LLM the style that you want the answer to be in. So that's the Data Studio. It's a reasonably, it has a good workflow, so you can actually go beyond just curation. You can actually prepare and create a nice workflow and then augment. Then another very powerful tool that team has put together is how you can use a real LLMs, fine-tuning your LLMs, but also using LLMs to generate a lot of your code. So CodeLlama, some of you have seen CodeLlama. This is basically using AI to generate applications, a simple dashboard. This is the wireframe of your, or a sketch of your app, and so essentially using Gen AI to generate the app itself, the dashboard itself. So folks like Plotly and others you've seen, this is a kind of able to help build those plots or Tableau plots or a Wave we produce, or Streamlit, sketch to Streamlit, sketch to Wave, sketch to kind of application generation. I think this kind of where the future is headed, where people can essentially use AI to generate AI, AI to even fine-tune some of these titles. You want to generate a title, this is a separate prompt for it. Uses H2O GPT to generate the title, appropriate title, so you can then start applying those to your applications. So I think it's a very optimal time, if you will. There's ever a time to be producer, be a maker. This is the time to be a maker, because you can absolutely 10x or 100x the impact you can have on the planet. Right? Generate a ggplot to script in Python for plotting temperature in Atlanta, right? And I think, I mean, time is absolutely ripe to be able to generate, have magnifying impact on your impact on the planet with the help of Gen AI and with the tool chain that's out there, both open and closed. You absolutely can produce an incredible amount of, you can produce impact that previously only kings and queens could have thought of. Other things that attract or we focus on, AI for good is a very key theme. That's exactly why we started the company. I started the company because my mom had breast cancer and we were fighting cancer with math. And I think we're super privileged that the world has allowed us to continue to be on that terrain. One of our customers is AT&T, and they use the entire end-to-end AI as a service with us. They gave us a problem on how to solve which telephone pole is likely to be hit by a hurricane. And we worked with Argonne National Lab and found out that the precipitation, the feature discovery came from AutoML. The precipitation 43 days before around the pole had a huge impact on when it's likely to crash. The way we built that model was using driverless AI, which is our AutoML platform. And I think many of you in the audience were pointing to that, the perfect convergence of where ML meets LLMs, where you can tell stories from features and use Shapley values to drive narratives and decisions. I think that's the place where we are heading towards, and H2O is driving an incredible piece of adoption there. This is one of our customers trying to predict their weekly sales. This actually is Kaggle contest, many of you have seen. This is a very powerful engine that we have built for feature engineering, feature discovery, bringing different models into the play, whether it's, and it runs a genetic algorithm across all the parameters. It also allows you to bring your own recipes. We have about 200 recipes that are open. We have a recommendation engine that can match TikTok in its capabilities and accuracy. Hundreds of recipes that you can make yours as well and bring your own recipes. But the idea behind this tool chain is how do you balance between accuracy, speed, and interpretability in your models? And you're able to kind of essentially use the tool chain to build really rich, high-grade models. The makers behind these engines, whether it is the LLMs or AutoML or Hydrogen Torch, which is another model framework, modeling framework I will introduce, are Kaggle grandmasters. The top 10 grandmasters, 5 of them typically are from H2O. What you're seeing here is nothing fancy. I mean, it looks fancy, but it's really good old-fashioned, kind of picking the right model, making sure you prevent leakage, making sure you prevent kind of overfitting by using reusable holdout sets, and essentially doing the grunt work of machine learning using a genetic algorithm. So it's a continuously and using the best platform. This particular problem, Light GBM, won over. It's also detected that the horizon forecast horizon is 39 weeks, and it's able to pick up lag variables and essentially run transformations. What it ends up actually delivering for you is consistency of modeling. Even when you lose a data scientist, you still have the best features being generated. In the hand of a naive or a new data scientist, it can produce models of incredible value. So, and it generates, like all of our other models, modeling framework, generates code from the model, so you can plug that code. And that was the code that we were seeing earlier being used in the application. So the idea is that from data to application, you're able to truly democratize the end-to-end value chain for your idea. And there's lots of models here. Predictive maintenance is a common one. If you see a lot of folks in the audience who are from the industry. We work with several manufacturing companies and car companies to ensure they have very good, powerful, predictive analytics on their factories and the factory floor. Supply chain, demand sensing, another common use case for us. Everything is Kubernetized. When I'm doing these demos, they're not real life. You're able to go and use these applications and co-create with us. I think the key aspect that we have found that works for our customers is our customers are not just consumers. They are making AI and AI platforms, AI infrastructure, and participating in our growth. So your data is actually very valuable, and the ability to use your data to build a rich outcomes is kind of where we are certainly super excited about. With that, I want to touch on a couple of things that actually are, when data is a team sport, a lot of what you're seeing, technology problems has been solved. It's the cultural ability to bring that transformation end to end. That's where leadership will be needed, courage will be needed to bring the change. Courage is still a very scarce resource, right? Sort of in the age of of Gen AI, prolific code being built, what is your moat? What is your IP? Prompt is your IP, right? So the prompts you're posing against a ChatGPT or a Anthropic or Claude 2 or H2 or GPT, that prompt is actually the IP because data is being synthesized. We're building a lot of models from synthetic data as well, which is very close to what you're seeing for real. And the one other biggest moat is customer and community. Community is the real moat. If you build a very strong community, that is your brand. That is the one that sticks with you when things are up and down. It's like the extended family. And that community, from that rose our customers. And these customers have been co-creating with us, and people typically live longer than companies. So the data scientists that we met years ago are now rising up the ranks. According to us, in 2030, every Fortune 500 company will be led by data scientists like yourself, data folks and AI engineers. This is going to be how the world is going to run. So every data scientist has risen up. We've been partnering with data scientists 10 years. They've risen up to be chief data analytics officers and are mostly sitting on boards. Our board actually has a PhD in data scientists from one of our own customers. So the problems of data are going to be how strategy is going to be evolving. So strategy science, how you take data science and start deploying it for decisions, but also creating stories that can lead to effective strategy. Today's strategy is reasonably ad hoc, and many of my customers, whether it's Chipotle trying to do the data science of what goes into a burrito, to Reliance, which is trying to figure out how to price each of their retail products, they are essentially doing problems at the local level. When that starts rising to the level higher, one of my customers out of Australia, they're trying to understand in the geopolitical tension between US and China, what are the things, what are the options they have? And they're trying to balance between risk, reward, and resilience of the decision. So taking data to decisions, both scenario planning and optimizations, as Venki in the audience will say, but beyond that, to actually create a cohesive way of driving strategy across boards, across your companies, across your whole organizations, that's the place where the road ahead is. I want to say that AI is actually your true co-founder. If you're a student getting, so I met a lot of students in the audience over the last couple of days, definitely everything is possible. And if you put your mind to it, nothing is impossible. And AI is a true co-founder for anyone with purpose and with a desire to transform the planet. So have courage and go change the world. Thank you.
Testing. Testing, 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 testing. 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 Test. What's that? Testing. Testing 1, 2. Testing, 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 testing. Is it too much? Testing, 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 testing. Do you want me to bump up the receiver? What sends to you? Do you? Testing, testing. No, I say like, do you want me to bump up? Because I can.
No, that's good. That's good.
So we're good?
Yeah, the signal we're getting here is good. I just gotta mix it as it comes in, but yeah, it's coming in fine. When does he come on? 4 o'clock? Right?
3:30. In 9 minutes.
The guy that needs this?
Well,
I thought he
the
could
next 2 guys will do this.
Oh, they will? Okay.
Mm-hmm.
Cool. All right. Yeah, pretty good.
So, I mean, this works both ways. You can plug this guy and you can keep it here, you know, and then you just clip this on, or you clip on the actual transmitter.
Yeah, let's do it that way.
All right, so let's do another test then. Actually, I can be over there, but you want to test for feedback, right? Yeah. Testing, 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 1, 2. We good? 1, 2. All right, Mr. Nick. To be really honest, I didn't think of it until you texted me, because we could have done it as soon as it broke.
Yeah.
The other one.
That's good. I will say the general was a little grumpy. He was very insistent about it.
Okay.
Like, offended that we back, oh, we got a hand mic. I was like, no. Like, you've got 40 minutes to figure it out. I'm like, oh, it's going to be one of those situations. It's going to be a fight. So, who will be happy to know that his wish has been granted.
Yeah.
Do I need this too?
Yep. So, can we park this so it doesn't rub against?
Yeah.
So this we can.
You can hide it somewhere here.
Yeah, we can use this, and then you can put that in the.
Okay. So I'll put this here.
Or that in the pocket.
Yeah, and I'll hide it here. Excellent. So I was talking to Hui Ming last week. Same old Home Depot.
Ready? And you tell me, does it change?
No, I don't know.
I'm wondering how, after a while like this, how you evolve after a while, because you just...
I just don't know with... were you there when Scott was there? With the new guy, the one who replaced
No,
Khalifa?
I haven't had any overlap with Scott.
I
have heard more of the business side. Am I
Yeah, I don't know.
Can we do a test real quick and make
1, 2, 1, 2. Do you love me? Do you love me? No. Are you testing me? Yeah, Sagapo. You know that I'm Greek? No, I say Nick. Where does it say Nick the Greek? Oh, yeah.
Of course,
Nick the Greek, yes. Hello, I love you. No. Love. 1, 2, 14.
Now I can't talk to you. No. Private.
All your secrets will be
Yeah.
revealed.
So where do I know you from? You used to videotape some of the meetups?
Yes.
Yeah, last I remember you.
For the last 11,
Yeah.
12 years? A couple years, maybe. One or two.
Well, the very first meetup, I don't think you were there, it was 2012. I was the first speaker of that. That used to be, you remember the Data Science Connect meetup?
Yeah, when Andrew Gardner was
Yes,
there.
yes. I was, before Andrew was the guy called Raj.
You okay if I move that mic a little bit?
Yeah, you can move that mic.
Because
Yes,
where it is now, we're going to get some feedback. I need it on your collar.
Feedback is good. You know, as long as it's
Good
constructive.
feedback. Good feedback is good.
Positive and constructive.
Right there.
Officer, you're choking me. That's unnecessary violence.
Temporarily.
Yeah. I know my rights.
They don't do something in Greece, right?
Yeah. Exactly.
But referencing my big friend when he's introduced Nick.
Nicky, exactly. That's how we are. So yeah, it looks like it was always kind of like a game of politics, you know, Home Depot. It was funny because I said, you know, look, I can tell you about more long-term what you can do, but I can show you how some of the clickstream you used to do with this, like pages of SQL, how you can do it with what we have right now in a few lines. They said, that's great, but what's the business value? I said, well, the business value that's actually you can do things that you couldn't do before. But for them, is like, that was always my struggle with Home Depot. And no, we have to go to the business and tell them. And that's why they never managed to, like anything we managed to do was because Khalifa was buying some buffer. Like he will take some risks, not too much, but more than anybody else. But I think since then, I mean, Wei Ming is all about, you know.
Pleasing the business. I mean, yes. Yes, there was a round table, I mean, panel around that. It's like, how do you get data science to demonstrate the ROI?
It's more like a management problem, you know, with the executives and people securing the. It's more about moving your.
Mindset. It's a mindset in the sense of what's the culture of the company, and who is taking the decisions, and what are the priorities. So in Home Depot, it's merchants who are taking decisions. So it's driven by merchants.
So it's not a technology company, and that's why I would always.
Yeah.
And yeah. So.
Still, I mean, at least when I left, it was.
I mean, we did a renovation, and I can tell you that was much easier for us to buy things from Amazon rather than from Home Depot.
Yeah.
Anything I needed, I didn't need immediately, so I didn't need a store. Oh, we get it from Amazon, not from Home Depot.
Yeah.
Home Depot was more the convenience that the store is around here, but.
Yeah. No, I mean, it's. I mean, I'm still sitting on a high potential things, and if they want to shift, it will go at a different speed.
Yeah.
They will still surf at their own speed because of the bulky things. I mean, I don't know how much you've bought from Amazon, but still, the bathtub, is still going to be delivered by Home Depot.
I don't know if I know there was a growth on the online during COVID, but I don't know if that has continued or if it kind of like went back.
It has not. I mean, I know from my Shopify
Yeah.
knowledge that it was on that ramp. It has at high peak because of COVID, but it has returned to what it was before.
Yeah, so for Home Depot, I don't think they had any.
No, I don't think it has. I mean, I don't know specifically for that, but people have returned to their own habits. Still with a continuous growth.
I just realized I forgot the multi-million call of the beast.
It is in the agenda, I believe.
Yeah. Let's see if I can. Let's see the power of internet. Might be able to.
Yeah, you added in the agenda.
The agenda is fine.
Yeah. All right, you have 1 minute.
So, can you reload the slides? Can you reload them, the slides? Just press, let's see if it's going to. a small change. Let's do a re. Is that like a?
You can edit maybe directly on his.
Is that a browser that you have over there? That's fine. That's okay. Leave it like that. That's okay. Don't worry. It's okay. It's okay. All right. Έλα εκεί, είμαι... Δίνω ένα τόκ τώρα. Θα πας εκεί. Ναι. Okay. Hey, Ron. Nice to meet you. Good to see you.
Anybody else here?
Not from the people you remember. I don't know. I don't think so. I'll catch up with you later. Hello. My name is Nick Vasiloglu. And I always wanted to be a rock star. Clearly, I failed. But I live very close with the organizers, and they said, well, we're having an event in October, but we've grown so much, we can't really find a venue. So I said, first of all, they asked me to talk. I said, that's fine. And then I thought, where would be the best place for me to give a talk? And I thought about center stage. So they came, they showed, they liked it. But unfortunately, I made it to the small stage. I didn't make it to the big stage. Last time I was here, it was like a Rick Astley concert. Anyway, so there's a small discrepancy between the title and what we have on the slides. I swear to you, it's a typo. So the concept over here is like answering questions on not multi-million-dollar databases, but multi-million column databases with knowledge graphs. And as we usually disclose when we buy food, you know, the presentation was produced at a facility that LLMs are present. So I also got cut over there. Okay, so there's a bit of LLM in the picture. I know there were a lot of talks about large language models today, so I prefer to talk less about them. So while we're enjoying the advances of generative AI, another revolution and paradigm shift is taking place kind of like silently that I'm not sure that everybody realizes, you know. 10, 15 years ago when I was actually working with my good friend Ron right across the street, it was the cloud revolution where, you know, the cloud was just like storage and compute and people were moving all their resources over there. And, you know, trillions of dollars were spent, companies became super big like Amazon. And the substrate was, you know, basically computers, you know, CPUs on demand and S3 storage on demand. But it seems to me that now nobody really talks about the cloud anymore. Everybody talks about the data cloud. And the paradigm here, the category leader is like Snowflake, where you put all your data over there and you start building applications on top of that. So people don't care anymore about the compute and the storage as is, but they care more about, you know, having their data over there and being able to manipulate the data without really having to care about deploying servers and databases and doing all the DBA management. I wanted to make something clear, which I realized I thought it was clear for most of the people, but apparently it is not. There's a big difference being, you know, a cloud-hosted versus cloud-native, okay? Still after, I don't know, 15, 20 years almost since the cloud came up, people still think that, you know, well, okay, that's fine. I can run it on the cloud. You know, I can go launch a machine on Azure, you know, Azure and AWS and do it. But When you are cloud hosted, it means that when something was built, it was built in order to run on a single machine, meaning that it will have the limited, it could be a very big machine. It doesn't really matter, but you're always constrained by the compute that number of CPUs that this machine has, cores, and the storage. But when you talk about cloud-based or cloud-native, it means that you are built natively on cloud services. You can't take Snowflake and run it on your machine. Snowflake will always run on the cloud because it wasn't designed to be like that. And that means that it uses basically infinite compute and infinite storage. Okay, everything is kind of on demand. You need to run a transaction. I mean, there's different billing models, of course, with BigQuery is another, of course, big cloud-native platform. So, if at some point you have a workload that needs 5,000 cores and, 1 petabyte of data, you can just pull your resources, run it, and then shut it down, and then you don't pay anything. So there's a lot of advantages being cloud-native. Okay, just keep that in mind. So right now, as I said, there's a paradigm shift where CDOs across the world, they realize that finally you can feed all your databases, anything you had, all your data into the cloud. Okay, so whether you are a Snowflake or BigQuery, and there's other players, I'm just mentioning these two major ones, you basically have everything in one database. That's like a huge thing. And the next question is that now that an analyst has 100 million columns available that they can access with a select SQL query, well, the next problem happens like, okay, how do I find what I need? I know that I can access it, but it doesn't mean that I can find it. And you might have heard of companies, data catalog companies, that they started doing this work for you, or at least providing the resources in order to do it. And the whole idea is that you start building an ontology, or something that we also call a semantic layer, in order to access it. And I think there were several talks today talking about how you can use a language model in terms of translating natural language to a SQL query that can translate it to SQL query and find your data. And I believe most of the people talked about the need of a knowledge graph. I'm saying preferably a relational one. I work for relational AI, and we are in a new category called relational knowledge graphs, which we'll talk a little bit towards the end. So another thing, like based on what we said right now, that is kind of like surfacing right now, is the modern data stack. So once you have all your data inside a cloud platform, okay, you have ways of ingesting them, transforming them, and then you have all these consumers. You have your BI tools, your notebooks, your ML feature engineering, your data apps that they're looking directly to the database. And it turns out that this is a problem. This is a problem because it creates a lot of noise and a lot of redundancy. Because you might have like an application talking about revenues, having a column name, might be cryptic. Then you might have like a feature engineering talking about the same thing and maybe using a slightly different formula. And in general, if you're just allowing all these consumers to read and write back to your database, you're creating more chaos. What we need, and I think it's becoming the standard right now, you need a semantic layer. So the semantic layer is like this ontology, like this thin substrate that we all agree what the vocabulary is going to be. Okay, I mean, we all have to agree what the revenue is, what constitutes a customer, what constitutes an active customer, and what are their relationships. It's usually something that is humanly readable, and it's quite, concrete and minimal. Okay, so here's the definition we give to an ontology. At least that's how we believe. The ontology is a collection of concepts, relationships, and business rules used by domain specialists in the course of their work. We believe that whether we want or not, every enterprise has an ontology, like every country has a language, a vocabulary. Whether it's model or not, it does exist in the heads or in the invoices or in the applications of the software of the business is running. And a model of that ontology will be familiar to any data consumer on the enterprise, okay? Well, nevertheless, few applications like what we see, and almost none of the enterprise data deliberately conform to that ontology. I probably don't have, I don't know if we have enough time. I don't want to, spend too much time on that. But concept, what is a concept? Is a subject or object of business utterance, a thing meaningful to business. The relationship is typically a verb, an action, a transition. And the business rule, it's kind of like, whatever a rule is. It's a formula, okay? Like if you are a cybersecurity company, this could be your ontology, like, where you're talking to people. Of course, it's a little bit bigger. I just put a sample, but that's an example. Now, there's lots of benefits by using this semantic layer. It's reusable. It reduces dramatically, I can stress that, the probability of an error. I don't know, if you work in enterprises, how many times have you seen things becoming wrong because, you thought that this column meant that, but it actually meant something else. There's no lineage, there's no provenance. It's very easy to share with people inside and outside of your organization. It turns out that it's very compact whenever you need to write queries, and that's something that we're going to talk a little bit towards the end. Like when you have millions of columns, we have super huge databases, and you have to create a query that traverses, 10 concepts. It's much more easy to generate that automatically, and in a way, it's a much compact way, 10 to 100x in the reduction of the code that you have to write. And of course, because it's, it's another layer, and it has a lot of information, sometimes it's even much easier to optimize the performance of whatever engine is going to execute queries on that. And of course, portability is the other thing. We're going to see that. There's, you have your semantic layer that you can, easily port it from, let's say Snowflake to BigQuery. And, a good indication that this is the way to go is probably the success of dbt. So the dbt is in the form of templatized SQL. There's other frameworks like LookML and Coalesce and Malloy and Prequel that basically, it's a new language, but they translate to SQL. It's a much more compact language, and that has the advantage of portability that I mentioned. And then, of course, there's the old school of the semantic web, Sparkle, RDF, all. They're still trying to get into the game, but I feel like that the modern frameworks have an advantage over there. And of course, there's Goldman Sachs has open source Legend, and I think Morgan Stanley has the Morpher, and we do have a language called RHEL at Relational AI as well, where basically you can translate to your SQL engine. Okay? Now, it's great. I hope I convinced you why it's good to have an ontology. But the question is, where do you find one? Okay? And I will admit, it is hard to do it manually. Okay? It is also not straightforward to do it with LLMs. Okay? You need kind of like a library of prompts. It's definitely much easier, okay? So it has lowered the bar, and a hybrid approach, like a human-in-the-loop approach, right now can actually help you, much faster than before, build your own ontology. One of the observations that we've seen when we go to companies that they have hundreds of millions of columns is the 99% of these columns are not really what we call core concepts. They're basically generated. Like if you think at a company, there's a few apps, like your website, customer service app or something else that generates, the core concepts, and everything else is derived from that. So typically, like if you start from the ones that they are the sources, then you can see what your queries are, and then you can automatically start creating, expanding your ontology based on these relationships. The process is simple. You start with the business experts. I think within a few weeks you can have your core ontology, and then the language models can do the heavy lifting, of course, with a human in the loop. And the other thing is, okay, we have the ontology. How do we evaluate it? That's something that you internally have to develop some benchmarks, like, for example, the easiest that everybody's talking. I have a set of 1,000 questions. Given that ontology, what percentage of these questions can be answered automatically, or things like that. Now, this is an example from a customer, and it kind of shows how they started from week 0 to week 23, and they managed to basically translate about 18,000 columns. You see that there's a sudden jump once they start understanding how to do it. And then it actually continues. I just put you the first 23 weeks of working that. Now, and that's without language models. Like now that we're putting language model, that gets even more accelerated. But what is interesting is that as they started slowly and they would see the benefits of the core ontology, now they start becoming more invested in that and spending more time and engaging more people to do that because they can see the value. And I just want to give you an example of how what we call semantic search, how like the ontology is helping you answer a question. The idea is that, this is obviously a simple ontology. You have customers, zip codes, CTN is the cell phone number, you have a call, you have an account, and you want to find the cell tower who receives most of the calls from customers who live in a specific address. You can take this graph, you can write it in this relation form, and you can ask it to, here I'm translating it to Datalog, you can do it in SQL. 3.5 has some problems, GPT-4 does a better job, and a different approach. But the problem with that approach is that as your ontology starts to increase and the queries become more complicated, they don't really fit in the prompt. And we all know that the language models, once you start filling your prompt window context a lot, they start making a lot of mistakes. So a different approach would be to take that query, say, okay, here's my query, here's my ontology. Bring me, you can do it in stages and say, bring me the things that are relevant about answering that query. And then in the end, once you bring those, you go back to your knowledge graph, and you can find how you can traverse it, okay? And basically, here it shows the path that they lead you to the concept that you're interested in. This is, there's several advantages. It requires much cheaper language models that you can deploy, on your premises, and, it's much cheaper. You don't depend on OpenAI or Cohere or whatever, Anthropic costs, okay? And I wanted here to revisit the initial slide where we basically talked about the modern data stack, okay, where we have this semantic layer that helps you basically serve all your consumers of your data. And what I've added over here is something that Relational AI has done. We are the coprocessor, the AI coprocessor for Snowflake. There was an announcement at the latest Snowflake Summit where basically we embed ourselves. Like I talked about the modern, data cloud. It's a big relational engine that can fit hundreds of millions of columns. Now, we go as close as to the core of that. And we're basically, you can think about, managing all these knowledge graphs and all these structured knowledge of semantic layers right in the core, in the security perimeter of Snowflake. There's something called Snowpark containers, which means that you don't have to, your data don't have to leave, go somewhere else and come back. You don't have to deal with your chief security officer having to do due diligence for another company and worry about all the other problems. So, so basically, we do, we can do graph analytics, we can do business rules, we can run optimization problems right in the core of your data. And of course, we serve the purpose of creating these semantic paths for feeding your language models and being able to answer your questions. This is some more information. We do support SQL. And with that, I would like to conclude my talk right on time, 3:15. I guess if we have 10 minutes, the next talk is at 4? Okay, all right, so you can ask me questions as I'm coming down. Okay, thank you.
Check, check. You want to check sound? Yeah, check, check. Check, check, check. Check, 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 check. Testing. 1, 2, 3, check, check, check. Hello, check. How boring do I sound? It's on.
You're good. We're just getting feedback.
Okay.
It's very sensitive. So.
It's like my car.
Like your car? What you drive? BMW?
Mercedes SL 550.
That's
like
it.
a princess. It, something little pebble and it starts screaming. Like shut up.
Yeah. Let's give that a go.
You're getting feedback from where? From
the mic.
No, like from the receiver. In like I don't understand.
So the
What am
mic
I
is-
close to? What do I need to do?
The mains are right here.
Ah, okay.
Yeah.
So maybe a little bit behind.
Yeah, the further back you stand,
The better it is.
Yeah.
If I go here, that's a problem.
Yeah, I'd probably try to stick behind the TV and up to like the TV line at the
Okay,
furthest.
fair enough.
Because it's so sensitive.
All right. You want to test again?
Yeah.
Test, test, check, check, test, testing, testing. Check, check. How's the feedback? Still there. Okay, testing. 1, 2, 3, test. I hear it. Well, that's one way to kick people out. Check, 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 test. Check, 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 test, check. Check, check. We good? Tell you a story. That's for the talk. Okay, good. I'm feeling good. How are you feeling? Listen, if I sound too boring, you can have some whiskey over there. Does that work for you? Well, today we're not going to talk about AI and blockchain. Everybody did already.
Yeah, that thing's really sensitive. So, I don't know how loud you talk.
I can get loud, but you don't want me to get loud.
It'd be better if you did.
Oh, I got you.
Because the signal to noise would be better.
I got you.
But if that doesn't react well, would you grab the handheld? Just.
Is that live?
It's muted right now, but this is already dialed in. It sounds great in this room.
Okay.
But just come over here and grab this.
Okay.
You don't need to stand up.
Yeah. Yeah. Well, I can modulate my voice if that's needed, and I can step back because I think camera is good to capture.
Okay. Yeah, we'll figure it out.
Yeah, just leave it there. I don't want it in the shot.
Cool. All right.
I can talk loud if that's what you want.
It would help.
Good. At least they'll pay some attention just because I'm loud. All right, guys, have a seat. I don't have the time, so somebody tell me. It is 4 o'clock. Okay, so it's time to go, I guess. Are you all ready? Wonderful. How about you guys in the back? the AV team. You all set? All right, guys, thanks for coming. My name is Roop Singh. And today we're not going to talk about AI or data or blockchain. I mean, you've heard that stuff all day, 2 days. I'm sure you're bored by now. And if I bore you further, there is some whiskey or vodka for you in the back. We specifically chose that room for that purpose. You know that, right? So, for those who don't know me, here's a quick background. I'm not going to go over it, but just take a quick look and then we can move on. So, without talking about data and blockchain and AI, let's talk about something you all like. Do you like movies? Anybody like movies here? All right, wonderful. Let's talk about movies then, shall we? Did you know that the earliest movies were silent? They were captured mostly using hand-cranked cameras. You remember that? The first motion picture camera was invented by Thomas Edison and William Dixon in 1891. It was called the kinematograph. Early films were often shown in private settings, just like these. The Lumiere brothers in France pioneered public film screenings in 1895. Editing was very basic. Most shots were single takes, long single takes. And then came sound. Did you know that Warner Brothers first released the feature-length sound film called The Jazz Singer? When? In 1927. Sound on film, like you know today, wasn't invented then. Sound was in fact initially recorded on separate phonographs and then synced with the film during projection. Later, the sound on film technologies like Vitaphone were developed where the sound was directly recorded onto the film. And then came color. The iconic movie Wizard of Oz, 1939, showcased the possibilities of color. And 1930 saw widespread adoption of color films with Technicolor leading the way. And then came, jumping a few decades on, home videos. You remember those cassette tapes and VCRs in the 70s and 80s? The medium of recording movies, visual and audio, changed. And so did change the business models. So did change the distribution of films. That was a major shift. And then jumping a few decades ahead, we got to digital cameras. The transition from analog film to digital filmmaking began in the 20th century with movies like Star Wars, Episode II, Attack of the Clones, being shot almost entirely on video, on digital cameras. And then came CGI, computer-generated graphics, around the same time. Remember Jurassic Park? How iconic and well-adopted that film was? And then moving on, you know the story. Then came CDs and DVDs and Blu-ray. What's changing here? The medium to capture an immersive experience. A shift in replication and storage and distribution of that media allowed for new and different business models. And then let's come to today, and came streaming, something you are now immersed in. Netflix, Prime Video, Apple TV, take your pick. So what was it? Was it just one technology that enabled the experience that you live today in your homes, in your car, on the airplane? It was advances in camera technology, sound recording, special effects, distribution methods that evolved to bring us the current state of the world, your current immersive experience, and the shift in business models and markets in an industry. So you get the story. It's a story of tech-enabled evolution, leading to scaling of distribution, new markets, business model. It's not just one technology that produced this. It's a synchronization of multiple different techniques, technology, concepts that arrived us here. It's a wave of different technologies. So now, let's look at three waves. artificial intelligence, blockchain, the ubiquitous nature of data. And let's ground ourselves in few terms so that we are all clear in this room what I mean by those. What is blockchain to me? It's a secure, immutable, encrypted, trustworthy, decentralized mechanism to share data. And for this discussion, I will include the functionality of smart contracts, which are essentially automated programs triggered by certain conditions or events. AI is a set of tools to generate cognition and decision making. And then data, that's the blood that runs through the veins, is the fuel that runs these engines to produce some relevant outcomes. And then what is disruption finally? Disruption to me is making the current model obsolete, as you saw in various waves of technologies in movies. So how are these different ways collaborating or enhancing each other? One simple way to look at AI plus blockchain is that blockchain can allow to record the decisions, the choices that AI systems are making. A lot of times these decisions are not apparent. But now, given that we can record this in a secure, trustable way, we can then go back and audit those decisions and learn further from those decisions. That's one view. Here's another view. If you look from a meta vantage point, where are we going? What is the equation? So the way I see it is the following. You have questions that you can ask for a context. You heard all day today and yesterday about various use cases. People are using data and AI to solve problems, right? That's the context of a question or a set of questions being asked. And what does it need? It needs two basic elements. It needs relevant, usable data. We'll look into that. And it needs a cognition or a learning model, what folks are calling here LLM, right? Together, they lead to a relevant outcome. So why are we discussing this? You know this stuff already. You've heard it all day. The question I am more interested in is who is going to win? What is the game theoretic aspect of this evolution? How are companies playing with each other? Who's competing? Who's cooperating? Where are the winners? We can solve for problems. Yes, great. Who's the winner? And as you think about those questions, let's talk about the two factors I said. Relevant, usable data. What does that mean? If the data is irrelevant for the questions you're asking, let's take some use cases. I want to predict the price of real estate in Copenhagen, in Medellin, or here in Atlanta. I need a set of historical data and a lot of other demographic factors, economic factors to feed into a particular learning model to output some results of what the prices might be, say, in this Midtown zip code. You get the point. Or take another example. This is an example of structured data. Let's look at an example, use case of unstructured data. What could that be? Let's do some sentiment analysis on social media networks to predict where the next elections might be, or to predict how the stock market might perform. That's an example of unstructured data, being the social media channels and social media conversations. Now, all of this seems interesting, but if there is no relevant and usable data, then the models can't learn anything. And I think that's part of the issue. A lot of the conversations today you've heard about semantics and semantic layers, right? So if you look at structured data, I think the problem that we as people and as corporations have created for ourselves are various schemas. Go back to when Lotus was invented, right? When relational databases were invented, when RDBMS was, the first thing ever, SQL, Oracle, etc. You get the story. We design schemas, we design multiple databases across different companies, and then we said, this is my view of the world, this is your view of the world, and we shall not talk. We introduced a very, let's call it a centralized model of data, and we made sure that nobody talked to each other. And then we had unstructured data. We didn't have computing capabilities to parse, or language models at that time, to parse unstructured data. So we came up with just structuring them. This led to more semantic heterogeneity. I'm sure you're familiar with that term. The level of words and the meanings of the words that we keep producing onto the internet or onto our enterprises kept changing, increase in semantic heterogeneity, and that leads to the solutions that you heard today, which are essentially, let's develop a semantic layer. The problem with that approach, everybody needs to agree to the same standards. Everybody needs to agree to the same semantic grammar, if you will, or semantic ontologies to talk to each other. Till you do that, you don't have what one would call relevant, useful data. So first factor is companies who can figure that out faster, smarter, are the ones that are going to win. Let's look at the next factor. Does data ownership matter? I own this data. The fact that now they're learning models, the data, training data becomes more relevant and highly priced. I cannot solve for these two use cases unless I have training data. So hence, whoever owns that data also knows that, and they will put a price on that data. Now here comes the conundrum. I have a young niece, her name is Amira. You give her a toy, she says it's mine. Right? That's how we behave. I generated that data, maybe you did, maybe you didn't. Because I have it, I have ownership of it, and hence it's mine. I will not give it to you. That becomes a question. The boundaries of the firm are evolving. The question for you is, are you going to share that data, sell that data, syndicate that data, or barter that data? If you have data today, somebody with their LLM needs that data, what are you going to do with it? Are you going to be in a centralized model where you control, and hence how do you produce value? Or you're willing to share the data, but what are the mechanisms of such sharing? Put a pin in that, we'll come back to that idea. Let's talk about LLMs. We're now at a stage where LLMs are learning models, essentially. Think of cognition developing learning models. They're getting more ubiquitous, they're getting more powerful, and some of them are getting to the stage where they can be more efficient even with not that much computing power. So today, it seems like large stacks of GPUs are needed to run language models, at least in some use cases, and that is an advantage today. But still, there are a lot of other models. If you look at Hugging Face, or you look at Mosaic ML, you'll find open source data models that can be run for as low of compute as on your iPhone. Point being, we are getting to a place that compute efficient LLMs will run on the edge of the network. What does that mean? That means LLMs will be more democratized. They will become eventually a commodity for most use cases. What that means, if it's available to everybody, including a small startup or a large company, then the small can look large, and the large might feel small. The scale at which they can compute becomes more efficient, and hence they can produce the same relevant outcomes that a bigger company might. So what that means for competitive advantage. Remember the question, who will win? And then we come back a full circle to, where is my data? So now, let's layer in blockchain. Blockchain, if you remember, is just an efficient, secure, decentralized mechanism to share data across multiple participants. So I think this is where we're going. Because the need for data and training data would be so high, there'll be a price, a value put onto that. It already is happening. We will eventually get to data marketplaces in every domain, every use case, given the context. So take a certain context. I want to solve for a certain kind of breast cancer, and I need certain kind of medical training data for that purpose. There's only 5 databases on this planet that have it. How do we acquire it? Well, there's a value to it now. They're willing to part with it, or at least let you parse it, but it will be done on a blockchain-based data marketplace. Does that make sense? Same for other use cases. Pick a use case. Now, some use cases are data might be ubiquitously available. You can scour the open web, but that would also become a question. So if you look at forums like Quora or Reddit, if you see the recent news, the community that runs Reddit said that they will not let APIs scour their data for free. Why? Because there is value to that. They have spent time, effort, energy creating that, so that becomes something that they now can sell. And they demand that. They understand that. So we are going to get to data marketplaces one way or another, and I believe to authenticate the veracity of the data that you are selling, you would need a blockchain-based attestation of that data. Even prior to giving access or selling it to somebody, you would need to prove that you have the data that you say that you have. And that's where blockchain-based and zero-knowledge-based proofs mechanism can actually assist in creating that marketplace. Now, moving on, if you look at the LLMs themselves, where do you think that is going? When Warren Buffett talks about AI as nuclear weapons, I agree with him in certain contexts. There's probably 0.1% of use cases that are that powerful. Typically, we talk about singularity or generative AI, general AI, which can destroy the universe, which can destroy the world that we know of it today. And yes, we need to put some guardrails, some boundaries to it. But those use cases are very far and few between. And yes, there should be more thoughtful ways of approaching those problems. Perhaps it is that once you're developing a new language model, a new learning model, you have to get it attested from some central agency, saying that it is safe to do so. That becomes a very difficult practical problem, but that is why we all need to come together to solve for it. For most use cases, 99% of use cases that are benign, compute is going to get cheaper and LLMs are going to get more ubiquitous. So you, along with your friend over there, could be running a big company just based out of the small compute capabilities that you have. So then who is going to win? Any thoughts, ideas? I think those who are going to win are going to look at these waves of technologies. Not just one, not look AI by itself, or blockchain, or in fact IoT by itself, but just the way in the movies, you have to look at synchronization of all the technologies that are here available now. If you look in history, every stage of technological evolution I mentioned for movies, you will find a litany of companies that did not adapt, who were hence disrupted. The shift from analog to digital is a famous one. But look at even cameras, from analog to digital cameras. Look at distribution from CDs to streaming, or sorry, from CDs to streaming. The first phase being from VCR and videotapes to CDs. So those vantage points, those milestones in the course of evolution remind us the strategic choices that we need to make. If you look at the three technologies together, you might find the answers. I'm here to ask more questions than give you answers, so I hope I've done my job. Thank you. If you have time, I'm open to take some questions. Oh, just so we are closing, I've been teaching this course called Blockchain Strategy for Business Leaders. It's a very comprehensive 13-module course. We're about to release the on-demand version of it, video on demand, so you can just click and buy and do the whole course. So we've taught a number of executives on how to use blockchain for strategic purposes. And I think blockchain strategy is a term that has not been really understood. Blockchain has been understood more as a technology versus as a strategy. So my book, Profits in Chaos, Blockchain Strategy to Soar, Survive Disruption, is about to come out. we take historical lessons like we did today and apply them to today's world and see what we can learn from it. There are a lot of frameworks and principles in this book. Any book you write about technology gets outdated pretty soon, so my intention is to write a book about frameworks and principles that stand the test of time. So if you're interested, just go to profitsinchaos.com and you can sign up for discounts and the early release. And let's keep the conversation going. You can find me on LinkedIn, or this is my link tree. You'll find a lot of my previous TEDx talks, lectures, articles, etc. Open to continue this conversation further with you guys. Thank you for being here. Yes, please.
So when we talk about blockchain, often we highlight immutability, tamper evidence. We don't often talk about the fact that it can automate trust relationships without an intermediate party.
Yes.
Can you talk to your thoughts about, what does highlighting that aspect of it lead to in terms of future capabilities, future types of relationships, capabilities, things like that? What's your thoughts there?
Yeah. I mean, blockchain, you're right that in these types of conversations, we often don't end up there. But to me, blockchain is the trust machine. In fact, there is an MIT article that came out, I think 2016, that had that title, right? Blockchain, the trust machine. And that is the central value proposition, if you will, right? So the conversation I have in my courses with a lot of executives is they tell me, and there's some of them are here in this room, they would say, that's a cool story, Roop, but we already have these capabilities. We already do these things. Why do we need something called blockchain? And I say, yes, you already do them, but at what cost? Remember this very basic idea of I have a system, I have a database, and then another company has a system, a database, another company has a system. I'm being simplistic. But the point is we have developed those multiple systems, and then we have overlaid business processes on top of them. Some of them are automated, a lot of them are manual, and hence that creates the inefficiency that we live in. So what we end up doing is reconciling data back and forth. We say, okay, I don't know what data you have. I don't know what you sent me. Let's reconcile. Every week, every month, every 3 hours, whatever the case is. And then we add humans on top of it. You say, okay, the computer did something, but you now go need to check what did the computer do and can we trust this or not, right? So essentially, we've created a lot of transaction cost in terms of compute, in terms of manual, human capital, et cetera, et cetera. Now, what does blockchain do? It's very simple. This is a shared wall. Once we agree on a transaction, it's published on the shared wall together, meaning you can see it, I can see it. There is no discrepancy on what this data is. There is no doubt, there is no confusion, there is no question. We must agree that this is the data, this is the state of transactions in this moment right now. Because of that, what you can do is you can simplify. You can take end-to-end business processes, which companies don't do because they are localized. They look at their company, perhaps they go to the next business partner. But if you have 28 business partners, you take them all and you put them all on a blockchain-based network and you say, when I publish the data, you all will have access to it. Or when any of us publishes it, we agree to the rules of what that means. Once we do, we all have this data on the shared wall. And that's what creates trust. That's what creates efficiency. And that's what creates the lack of the need to reconcile over and over again. Right? Does that make sense? Yeah. Anybody else? Yes, please. Define loss prevention. In which context, in which use case? I look at that as authenticity of the product itself. So take a look at luxury goods, right? A luxury handbag, you know, a Louis Vuitton handbag, or take your pick, or even an iPhone for that matter, or even a high-end Rolex watch, right? Or Swarovski crystals. Take any good. What is the authenticity of that product? How do we know that that is what we say it is? So there are a number of use cases in that regard. In fact, each one of these I mentioned is already a developed use case using blockchain. And what you really need to do, particularly in the case of diamonds, and you can apply the same principles in other products, from the mine, from where the raw material started, you need to start automatedly, not humanly, automatedly putting data onto the chain. So by the time it processes through the mines, through the cutters, through the wholesaler, comes on to your shop where you buy it, there's a barcode, you can scan it, tells you the provenance of that one diamond. It tells you how it was found, where it was found, and the process it took to get there. And hence, you as the consumer can then trust the veracity, the authenticity of such a product. And you can apply it to anything, really. Food, medicines. Think about counterfeit medicines. How deeply impactful would that be? So I think those use cases are in a lot of cases already there. I also think AI will help accelerate that phenomena. It will help accelerate the authenticity, because let's take a case of a rare painting, right? How do we know that's a Van Gogh painting? We usually use, in the current world, we use some kind of an auditor, some expert to analyze the painting and say, okay, this is a real Van Gogh painting. And we usually trust them. So we have abdicated the trust to a third party. But what is now happening is we would use AI-based engines and AI-based tools to authenticate the first instance of this Van Gogh painting as being true. And then we will put a digital twin of that painting onto the chain, which we can then track the provenance of and the sale of as time goes on. Does that make sense? Okay. Anybody else? Yes, sir.
Where does privacy fit in that world?
Oh, my friend, how much time do you have? I often ask the question to my friends in Silicon Valley, is privacy dead? Right? So if you're interested in that, watch my first TEDx talk, which is basically on identity and privacy. Right? Is privacy dead? Should we not expect it anymore? Who cares? Right? We've all given up on the idea. There's a leak and a hack every second day. I've lost track. Like, I used to talk about it, count it, record it, There's no point, is it? Because the basic model is broken. The model being a centralized model of storing data. We store a data, a company like Equifax stores the data in a centralized place. Are you from Equifax? Wonderful. We would love to have a conversation. You stored some data, which, by the way, just so you know, you had no legal right to. That's a separate conversation. But anyhow, you got my data. Somehow you did. And you got everybody else's data in this room. You stored it, but then you couldn't protect it. Why? Because he said, here's an X. That's where all the jewels lie. The thieves came and took all the jewels. And you said, oops, sorry, the thieves took the jewels. Cheers. I'm sorry, but nothing else to do. The entire model is broken. So what needs to happen is essentially self-sovereign identity, which is the consumer, the user, which is me and you. We choose who we want to share the data, what data do we want to share, and we need to have the ability to retract that data. It is for a particular use. Yes, if I want to apply for a mortgage at a financial company, sure. I should be able to give them my financial data. They should be able to use it for the purpose of giving me mortgage. But tomorrow, if I decide I don't want that house or I don't want to work with that company, I should be able to retract that use of the data forever. The company has no right on that data. So the question is, whose data is it? Right? And that's essentially my first TEDx talk. And I say, data that is organic and natural to you, you have every right to own it. This is financial data. Let's take the step further. Let's talk about your DNA or the print of your fingers or the pattern of your iris. Whose data is that? Let's go further. Let's talk about your hologram, your digital twin. Let's say you are Tom Cruise and there's a digital twin, or a past actor, like let's say you were Michael Jackson, or take your favorite actor who's not alive anymore, actor or actress, and somebody claims their hologram. Well, nobody claimed it first, so it's mine. The question is, whose data is it, right? So I think privacy-preserving technologies are possible. They are being implemented. If you look at identity-based blockchain solutions, there is a whole litany of them in the last 10, 12 years. But to me, the question is not even of technology. The question is the underlying business models. The business models of companies like our friends at Equifax and plenty others are designed on the fact that they can just take our data and use it and not give us anything in return. So unless we address the underlying business model, nothing will change. Yeah, laws can, regulatory regimes can change it, and you'll see the difference coming from places like Europe. So if you see, GDPR 2 coming, even in the United States, the California protection law, et cetera, but look at the lobbying against it, right? There's a give and take there. So you know the story there. Anyways, anybody else? More thought-provoking questions?
Nostr?
I can't hear you.
Nostr?
I can't hear you again.
N-O-S-T-R? Nostr? Are you familiar?
Nostr. No, it doesn't ring a bell. Okay.
It's effectively key pair encryption applied to social media.
Sure, yeah.
Distributed on a distributed network of nodes.
Right.
So that you can't be censorable, or if a node is shut down, that it's effectively copied and duplicated, so that this whole idea of canceling free speech
Right.
is impossible.
Right.
Well, we don't know yet.
Right. So great point. And actually, this kind of is relevant to the talk as well. What is the model there? The existing model has been, if you look at how the web evolved, we had a layer called TCP/IP, right? We all assume that that's the protocol we're going to use to talk on. And then we developed layers of application on top of that. Facebook, Twitter, Instagram being those such applications. There are two things. One, we never included an idea of privacy or identity in that layer. And two, we actually never included the idea of money or money transfer, digital cash transfer in that layer. These are two basic inherent challenges that led to the world of Web 2.0. There are companies that came up and solved for those challenges, right? So if you look at what was eBay, eBay was a solution to that challenge. I mean, sorry, not eBay, PayPal, right? To the money challenge. To the question you're asking or pointing out, there's a centralized model. That's what we lived on today, which is essentially these companies that have centralized solutions and centralized governance and centralized authority. So I'm neither for free speech or against free speech. That's not even the question. The question is, who is the decision maker? Who decides what is what, right? And in a centralized model, the world that we live in, that's what you get. We are moving towards, hopefully, to a more decentralized model. And we'll see how far we get to it. But if you see how AI is helping that picture, given the acceleration of AI and blockchain together, we can get to what some folks are calling decentralized AI. So computation at the edge of the networks, and decision-making and governance at the edge of the networks, which is what you're talking about, versus at a centralized authority, right? And that is the view. It might be a ubiquitous ideal, but we'll see where we get to it or not. Okay, anything else? Thank you, guys. Thank you so much. This has been fun.
Pleasure. No, I mean.